Hello there, and welcome back to Sleepy Discovery. Tonight, we are going to slow everything down and take a gentle journey into the fascinating world of chocolate. Chocolate is something many of us know intimately. We recognize the sound of a wrapper opening, the smoothness of a piece melting on the tongue, the familiar sweetness of a chocolate bar, and perhaps even the comforting smell that fills a kitchen when chocolate is being baked. But behind that familiar treat is a remarkably complicated story. Chocolate begins far away from the candy aisle, in warm tropical regions where cacao trees grow beneath humid skies. It passes through flowers, pods, seeds, fermentation, drying, roasting, grinding, mixing, and countless human decisions before it becomes the chocolate we know. And along the way, chocolate connects agriculture, chemistry, history, culture, biology, geography, and even a little bit of mystery. So tonight, there is no need to rush. Let your breathing become slower. Let the day become quieter. Imagine yourself somewhere peaceful, perhaps in a small room with soft rain outside, while we wander through the history and science of one of the world's most beloved foods. There is no quiz tonight. There is nothing you need to remember. Simply listen. And as the story moves gently from one idea to another, you may find yourself drifting closer and closer towards sleep. Chocolate begins with a tree. That might sound surprising because most chocolate does not resemble anything that grows on a tree. A chocolate bar looks polished, uniform, and manufactured. A truffle can look like a tiny piece of art. Hot chocolate appears as a smooth, dark drink. But all of these things begin with the cacao tree. The scientific name commonly associated with the cacao tree is Theobroma cacao. The name Theobroma comes from Greek roots that can be translated roughly as food of the gods. It is a wonderfully dramatic name for such a quiet tropical tree. Cacao trees naturally prefer warm, humid environments. They are associated with regions close to the equator, where temperatures remain relatively stable and rainfall can be plentiful. Unlike some crops that thrive under intense, unobstructed sunlight, cacao trees often grow naturally beneath the canopy of larger tropical forests. This means that a cacao plantation can have a very different feeling from a wide-open agricultural field. Instead of endless rows beneath a completely exposed sky, cacao may grow among shade trees and other vegetation. The cacao tree itself is not enormous compared with many forest trees. It is usually a relatively small evergreen tree, which makes it easier for farmers to manage and harvest. Its leaves are broad and green, and under the right conditions the tree can produce flowers and fruit directly from its trunk and larger branches. This unusual characteristic is called cauliflowery. Instead of flowers appearing only at the ends of young branches, cacao flowers can emerge directly from older woody parts of the plant. Imagine walking through a tropical cacao grove and seeing tiny flowers attached to the trunk itself. It is one of the details that makes the cacao tree particularly fascinating. The flowers are small and delicate. They do not look anything like a finished chocolate bar, and only a fraction of the flowers that appear on a cacao tree will eventually become mature cacao pods. That means the journey from flower to chocolate is far from guaranteed. The tree has to grow. The flowers have to be pollinated. A developing fruit has to survive. The pod has to mature. The seeds inside have to be harvested and processed correctly. And eventually, those seeds have to make their way through a long chain of transformations before chocolate appears. So when you eat a piece of chocolate, you are not really eating something that simply comes from a tree. You are eating the result of an elaborate biological and human process. The fruit of the cacao tree is called a cacao pod. Cacao pods can vary considerably in appearance. Depending on the variety and stage of maturity, they may be green, yellow, orange, red, purple, or combinations of these colors. Some pods are smooth. Others have pronounced ridges. Some are relatively elongated, while others are more rounded. A mature cacao pod can look surprisingly decorative, almost as though someone designed it specifically for a tropical botanical garden. Inside the pod is where the important part begins. When a cacao pod is opened, it contains a collection of cacao seeds surrounded by a pale, juicy pulp. The seeds are sometimes called cacao beans, even though botanically they are seeds rather than true beans in the ordinary sense. This is one of those little details that becomes more interesting the longer you think about it. The thing we call a cacao bean is actually a seed, and those seeds are surrounded by sweet, sticky pulp. Fresh cacao pulp does not taste like a chocolate bar. It can have fruity, sweet, sometimes tangy characteristics. The flavor can vary depending on the cacao variety, growing conditions, and other factors. This is important because chocolate does not begin with chocolate flavor. The characteristic flavor we associate with chocolate develops during processing. The fresh seed is only the beginning. Once cacao pods are harvested, farmers remove the seeds and pulp from the pods. Then something extraordinary happens. The cacao seeds are fermented. Fermentation is one of the most important steps in the development of chocolate's eventual flavor. It may sound strange to imagine fermentation as part of making chocolate. We often associate fermentation with foods and drinks such as bread, yogurt, cheese, coffee, tea, wine, or certain vegetables. But fermentation also plays an essential role in cacao processing. Fresh cacao seeds are placed together, often in piles, boxes, baskets, or other carefully managed arrangements. The surrounding pulp provides sugars that support microbial activity. Various microorganisms participate in the fermentation process. Yeasts are involved early in the process, helping transform sugars and producing compounds such as alcohol. Other microorganisms become important as conditions change. The process generates heat. Acids develop. The internal chemistry of the cacao seeds changes, and gradually, the raw seeds begin transforming into something capable of producing the familiar aroma and flavor associated with chocolate. This process is not simply about preserving the cacao. It is part of creating the foundation of chocolate's flavor. Without proper post-harvest processing, cacao can develop undesirable characteristics. Fermentation is therefore one of the quiet stages that deserves much more attention. The seeds may sit inside a pile or box while the biological activity continues. Farmers and processors may monitor the process and sometimes turn the cacao to help maintain appropriate conditions. The exact methods can vary greatly from one region to another. Temperature, timing, cacao variety, climate, farm practices, and fermentation method can all influence the final result. So even before cacao reaches a chocolate factory, many factors are already influencing what the finished chocolate might taste like. After fermentation, cacao seeds need to be dried. Drying reduces moisture and helps prepare the beans for storage and transportation. Traditionally, cacao can be spread out in the sun. Imagine rows of cacao beans lying across drying surfaces beneath a warm tropical sky. Farmers may turn them periodically so that drying happens more evenly. The beans gradually change in appearance as they lose moisture. At this point, they still do not look like the chocolate products found in stores. They are still agricultural material waiting for another transformation. The journey continues. Eventually, dried cacao beans can be transported to processors. There, one of the most important flavor-building steps takes place: roasting. Roasting cacao is somewhat comparable to roasting coffee in the sense that heat causes complex chemical reactions that transform aroma and flavor. But cacao has its own chemistry and its own characteristic roasting requirements. When cacao beans are heated, numerous compounds react and change. Some aromas become more pronounced. Others are transformed. The deep, familiar smell that many people associate with chocolate begins to emerge. The kitchen-like aroma of warm chocolate is therefore not simply sitting inside a raw cacao bean waiting to be released. Much of that familiar character is created through processing. This is one of the most fascinating things about chocolate. Its final flavor is partly the story of the cacao tree and partly the story of what humans do to the harvested seeds. After roasting, the outer shells of the cacao beans are typically removed. The inner portion is called the cacao nib. Cacao nibs are small pieces of roasted cacao seed. They are intensely flavorful, but they are not the same thing as sweet chocolate. They can taste bitter, nutty, earthy, roasted, fruity, or complex depending on the cacao and processing. If you have ever tasted cacao nibs on their own, you may have noticed how different they can be from a conventional chocolate bar. This difference helps explain something important. Chocolate does not get its familiar sweetness simply because cacao naturally tastes sweet. Instead, chocolate makers combine cacao with other ingredients and carefully manipulate the physical and chemical properties of the mixture. The cacao nibs are ground. As they are ground more and more finely, their structure changes dramatically. The fat naturally present in cacao, known as cocoa butter, begins to play a major role. Grinding produces a thick mixture known as cocoa mass, cocoa liquor, or chocolate liquor, depending on terminology and context. Despite the word liquor, this material contains no alcohol. It is essentially a concentrated cacao product made by grinding roasted cacao solids. This is another little linguistic surprise hidden inside the world of chocolate. Chocolate liquor is not a drink. It is a cacao material. The grinding process can transform solid pieces of cacao into a flowing or paste-like substance because the cocoa butter becomes released and distributed throughout the mixture. Cocoa butter is the natural fat found in cacao beans. It has unusual physical properties that make it particularly useful in chocolate making. One of the reasons chocolate melts so pleasantly in the mouth is related to the behavior of cocoa butter. Its melting characteristics are closely connected to body temperature. That is why a piece of chocolate can remain relatively solid in your hand for a while, but begin to soften rapidly once it reaches the warmth of your mouth. The experience feels almost effortless. A firm piece becomes smooth. The texture changes. Aroma is released, and the chocolate seems to disappear. This simple sensation is the result of complex physical chemistry. Chocolate is a food where temperature matters enormously. Chocolate makers therefore spend considerable time controlling temperature during production. One especially important process is tempering. Tempering is the controlled heating and cooling of chocolate to encourage cocoa butter to form desirable crystal structures. Cocoa butter can form different crystal arrangements. Not all of them produce the same texture or appearance. Properly tempered chocolate can have a smooth, glossy appearance and a satisfying snap when broken. It can also melt in a pleasant, controlled way. Poorly tempered chocolate may become dull, soft, streaky, or develop pale-looking patterns on the surface. Those pale patterns are sometimes called bloom. Bloom does not necessarily mean that chocolate has become unsafe to eat. Instead, it often reflects changes in the fat or sugar structure. Fat bloom can occur when cocoa butter or other fats migrate and recrystallize. Sugar bloom can occur when moisture causes sugar to dissolve and later recrystallize on the surface. The result can look like a dusty white coating. For someone unfamiliar with chocolate chemistry, this can be surprising. A chocolate bar can look dramatically different even though the basic ingredients are still there. Temperature, humidity, storage conditions, and time can all influence its appearance. This is why chocolate storage is more complicated than simply putting a bar wherever there is space in the kitchen. Chocolate generally prefers stable, moderate conditions. Extreme heat can soften or melt it. Moisture can cause problems. Strong odors can also matter because chocolate can absorb surrounding aromas. A chocolate bar stored beside strongly scented foods may eventually develop unwanted flavors. Chocolate is therefore not completely isolated from its environment. It can interact with the world around it. This is particularly interesting because our perception of chocolate is not based only on taste. Smell plays a major role. When chocolate melts in your mouth, aromatic compounds travel upward through the back of your throat toward the nasal passages. Your brain combines taste, aroma, texture, temperature, and other sensory information into the experience you simply call chocolate. This means that the flavor of chocolate is partly constructed by your brain. The tongue detects certain basic taste sensations. But the enormous complexity of chocolate flavor comes from many aromatic molecules. That is why two chocolates with similar amounts of cocoa and sugar can taste completely different. Cacao's growing environment matters. The soil matters. The climate matters. The genetics of the cacao tree matter. Harvesting matters. Fermentation matters. Drying matters. Roasting matters. Grinding matters. Recipe formulation matters. Storage matters. And finally, your own senses matter. Chocolate is therefore not one flavor. It is an entire family of flavors. Some chocolates can have notes reminiscent of berries. Others may suggest nuts. Some can be floral, some earthy, some spicy, some woody, some fruity. Others may have roasted, caramel-like, or coffee-like impressions. Professional chocolate tasters often describe these characteristics carefully, but you do not need specialized training to notice differences. Even a casual comparison between two different chocolates can reveal how dramatically cacao can vary. The history of cacao is also remarkably old. Cacao has been used by people in the Americas for thousands of years. Long before modern chocolate bars, ancient cultures prepared cacao in very different ways. Cacao beverages could be bitter, spiced, frothy, or combined with other ingredients. They were not necessarily sweet in the way many modern chocolate products are. This is one of the biggest differences between ancient cacao traditions and modern chocolate culture. Today, when many people imagine chocolate, they picture sweetness. Milk chocolate, chocolate cake, chocolate cookies, chocolate ice cream, chocolate truffles, chocolate-coated snacks. But cacao's earlier culinary history was often centered around beverages and savory or spiced preparations rather than candy. The word chocolate itself has a long and complicated linguistic history. Its precise origins and pathways through different languages have been debated by scholars. European encounters with cacao eventually helped spread chocolate across the Atlantic and into new cultural environments. Once cacao reached Europe, people experimented with it extensively. Sugar became increasingly important. Different spices and flavorings were introduced. And over centuries, cacao transformed from an unfamiliar American ingredient into an important European luxury. For a long time, chocolate was associated with wealth and social status. It was not something everyone could casually purchase at a grocery store. The modern chocolate industry developed gradually through technological changes. Machinery made it possible to process cacao on a much larger scale. New methods improved consistency. Manufacturing innovations changed the texture of chocolate. And eventually, chocolate became accessible to much broader populations. One especially important development was the creation and popularization of milk chocolate. Adding milk solids changed the flavor, color, and texture of chocolate. Milk chocolate is generally lighter and sweeter than dark chocolate, although exact formulations vary considerably. Dark chocolate can contain a higher proportion of cacao components and may have a more intense flavor. White chocolate is an interesting case. It generally contains cocoa butter, but does not contain the cocoa solids that give dark and milk chocolate their characteristic brown color and much of their cacao flavor. Because of this, white chocolate is chemically and sensorially quite different from conventional dark chocolate, even though cocoa butter connects it to the cacao bean. So when people talk about chocolate, they may actually be referring to several very different kinds of products. And the percentage printed on a dark chocolate package tells only part of the story. A label such as 70% cacao indicates the proportion of cacao-derived ingredients, but it does not automatically tell you exactly how the chocolate will taste. Two chocolates with the same cacao percentage can taste remarkably different. One might be fruity and bright. Another might be earthy and bitter. Another could have roasted or nutty characteristics. The percentage is useful information, but it is not a complete description of flavor. There is also a fascinating relationship between cacao and geography. Most cacao production takes place in tropical regions. The major producing areas include parts of West Africa, Latin America, and Asia. Cacao production is closely tied to climate. The cacao tree needs particular environmental conditions to thrive. This makes chocolate production vulnerable to changes in weather and agricultural conditions. A chocolate bar sitting quietly on a shelf may therefore depend on a complex global agricultural system. Behind that wrapper are farmers, processors, transportation networks, manufacturers, distributors, retailers, and many others. Chocolate may feel like a simple comfort food. Its supply chain is anything but simple. Many cacao farms are relatively small. Farmers may grow cacao alongside other crops. Agroforestry systems can combine cacao with shade trees and other plants. This can create more diverse agricultural environments than a simple monoculture. Shade trees can influence temperature and humidity around cacao plants. They can also provide habitat for wildlife. But agricultural systems vary enormously, and sustainability depends on many factors. The future of cacao farming is closely connected to environmental conditions. Climate change is one of the major concerns. Changes in rainfall patterns, temperatures, pests, diseases, and extreme weather can affect cacao production. This is another reminder that chocolate is connected to much larger planetary systems. When you eat chocolate, you are participating in a food system that begins in tropical ecosystems. The humble chocolate bar, therefore, connects your kitchen to forests thousands of kilometers away. And perhaps that is one of the most beautiful things about food. A small bite can contain an enormous journey. There is another remarkable part of the cacao story hiding in plain sight. The cacao tree does not produce its fruit in the same way many familiar fruit trees do. Its flowers can grow directly from the trunk and larger branches, and the developing pods can also hang from these woody areas. This unusual growth pattern makes cacao plantations visually distinctive. A mature pod can look almost like a colorful ornament attached to the tree. Inside, the seed sits surrounded by sweet pulp, waiting to begin another transformation. The cacao seed itself is rich in fat. A significant portion of its composition is cocoa butter. This natural fat is one of the reasons cacao is so valuable for chocolate production. But cacao also contains many other compounds. Among them are methylxanthines such as theobromine and caffeine. Theobromine is particularly characteristic of cacao. It is chemically related to caffeine, but has different effects in the body. Cacao also contains polyphenolic compounds, including flavonols. These compounds have attracted considerable scientific interest. But chocolate research needs to be interpreted carefully. The health effects of chocolate depend on the type and amount consumed, the composition of the product, and the broader dietary context. A small amount of dark chocolate is not nutritionally equivalent to a large candy bar loaded with sugar and other ingredients. The word chocolate covers a huge range of products. That distinction matters. Cocoa powder is another fascinating cacao product. After some cocoa butter is removed from cocoa mass, the remaining material can be processed into cocoa powder. Cocoa powder can then become an ingredient in baking, beverages, desserts, sauces, and many other foods. There are different types of cocoa powder, including natural cocoa powder and alkalized cocoa powder. Alkalization, sometimes called Dutch processing, changes the acidity, color, flavor, and chemical characteristics of cocoa. This can produce a darker-looking powder with a smoother or less acidic flavor. Natural cocoa powder tends to retain more of its natural acidity. The difference becomes particularly important in baking because acidity can interact with leavening agents. So even something as simple as a spoonful of cocoa powder can influence the chemistry of an entire cake. Chocolate baking is full of these quiet interactions. Sugar affects sweetness and texture. Fat affects mouthfeel. Cocoa solids contribute color and flavor. Milk ingredients influence creaminess. Emulsifiers can help manage texture and flow. Temperature determines how chocolate behaves. And tiny differences in formulation can change the final product. This is why professional chocolate making is both an art and a science. A chocolatier may pay close attention to particle size. Chocolate particles need to be small enough to create a smooth sensory experience. If particles are too large, chocolate can feel gritty. Modern chocolate manufacturing, therefore, uses sophisticated grinding and refining techniques. Conching is another traditional chocolate-making process. During conching, chocolate is mixed and worked for an extended period. This can improve texture and influence flavor by promoting the evaporation or transformation of certain volatile compounds and reducing some undesirable acidic notes. The process was historically associated with machines that resembled shells, which is where the term conching comes from. The exact methods used today can differ considerably from historical processes. Still, the underlying idea remains fascinating. Chocolate can be transformed not only through ingredients, but through controlled mechanical treatment. The final texture of a good chocolate bar is therefore the result of many small decisions. Particle size, fat distribution, crystal structure, mixing, refining, temperature, cooling, packaging, storage. All of these influence what happens when the chocolate finally reaches your mouth. And your mouth is an extraordinary environment for chocolate. Warmth begins to soften the cocoa butter. Saliva interacts with the chocolate. Aroma compounds are released. The tongue senses sweetness, bitterness, and other taste qualities. The brain receives information from multiple sensory systems at once. Texture changes from solid to soft to liquid-like. And within moments, something that began as a firm piece of chocolate can seem to vanish. That disappearing quality is one reason chocolate can feel so luxurious. It does not simply sit on the tongue. It changes. A piece of chocolate can begin with a crisp snap. Then it becomes smooth, then warm, then aromatic, then almost completely gone. The experience is brief, but the science behind it is anything but simple. Even the snap itself can tell you something. Well-tempered chocolate tends to fracture in a clean, crisp way. The sound comes from the structure of the chocolate. A poorly tempered or improperly stored chocolate may break differently. So the familiar snap of a chocolate bar is not just a satisfying sound. It can be a small clue about the physical structure of the cocoa butter crystals. There is also an interesting reason chocolate is often described as melting in your mouth. Cocoa butter has a melting range that overlaps closely with human body temperature. That gives chocolate its distinctive behavior. It can remain solid at room temperature under suitable conditions, but melt readily when warmed. This property is useful far beyond candy bars. Cocoa butter is also used in confectionery coatings, fillings, cosmetics, and pharmaceutical applications. The cacao bean therefore provides materials with uses that extend well beyond chocolate itself. And yet, for most people, cacao remains emotionally connected to chocolate. Chocolate is associated with celebrations, birthdays, holidays, gifts, romantic occasions, comfort, desserts, childhood memories, late-night snacks, a warm cup of cocoa on a cold evening. This emotional side of chocolate is fascinating because it is partly cultural. Different societies have developed different traditions around chocolate. The same ingredient can represent luxury in one setting, childhood comfort in another, and ceremonial food somewhere else. Chocolate has become part of global culture. Its journey from tropical cacao tree to worldwide symbol of indulgence is one of the great food stories in human history. And perhaps the most peaceful way to think about chocolate is not as a candy bar, but as a long journey. Picture the cacao tree quietly growing beneath tropical shade. Picture tiny flowers emerging from its trunk. Picture a developing pod slowly changing color. Picture the pod being opened by hand. Picture the pale pulp surrounding the seeds. Picture the seeds beginning fermentation. Picture warm, tropical air passing over drying cacao. Picture the beans being transported. Picture them slowly roasting while their aroma develops. Picture the shells being removed. Picture the nibs being ground. Picture cocoa butter being released. Picture the thick cacao mass becoming smoother. Picture ingredients being blended. Picture chocolate being refined. Picture it being tempered. And finally, picture a small piece cooling into its familiar shape. The entire journey may have taken months, years of agricultural care, and countless human decisions. Yet the final experience lasts only a few moments. A bite, a taste, a little sweetness, a little bitterness, a soft aroma, and then silence. That is the quiet miracle of chocolate. Something so ordinary in modern life can have such an extraordinary origin. And as we continue this sleepy journey, there will be much more to discover. We will wander deeper into the cacao tree itself, explore the ancient cultures that first treasured cacao, follow chocolate as it traveled across oceans, uncover the chemistry behind its flavors, and explore why different chocolates can taste so dramatically different. For now, though, let the story slow down. Imagine the tropical forest again. The air is warm. Leaves move gently overhead. Somewhere beneath the canopy, a cacao tree stands quietly. Its roots are hidden beneath the soil. Its leaves move with the breeze. Its trunk carries small flowers. And somewhere on its branches hangs a cacao pod, patiently developing. Inside that pod are seeds. Inside those seeds is cocoa butter. Inside the chemistry of those seeds is the potential for aroma, flavor, texture, and eventually chocolate. The process does not hurry. Nature rarely does. A tree grows slowly. A fruit develops slowly. Fermentation takes time. Drying takes time. Roasting takes time. Grinding takes time. Tempering takes time. And perhaps chocolate has something to teach us about that. Some of the most familiar things in our lives are the result of processes that we rarely see. The chocolate in your hand is the visible end of an invisible journey. So tonight, there is nothing you need to accomplish. You can simply rest. Let the thought of the cacao forest fade gently into the background. Let the sound of the story become softer. And if your eyes are becoming heavy, there is no need to fight it. The cacao trees will still be growing. The forests will still be breathing. The chocolate story will still be waiting. And when we continue, we will wander even deeper into this remarkable world. For now, take a slow breath. Relax your shoulders. Let your hands become still. And allow yourself to drift. The story of chocolate is long. And tonight, we have only just begun. If you are already comfortable, let yourself settle a little deeper. There is no need to concentrate too hard. You can simply listen as we continue wandering through forests, farms, ancient traditions, scientific discoveries, and the gentle transformations that eventually turn cacao into chocolate. Our journey now takes us further back in time. Long before chocolate became a wrapped bar sitting on a supermarket shelf, cacao was already part of human life in the tropical Americas. The history of cacao is deeply connected with the civilizations of Mesoamerica. People living in these regions cultivated cacao, prepared beverages from its seeds, traded it, and incorporated it into cultural traditions. Cacao was not simply another ingredient. It could have social, economic, and ceremonial importance. Imagine a world without chocolate bars, candy stores, vending machines, or chocolate cake. There is no foil wrapper, no colorful packaging, no familiar rectangular bar. Instead, there are cacao pods growing in warm forests. Inside each pod are seeds surrounded by pale pulp. People discover ways to process these seeds into a drink. The experience is completely different from modern chocolate. The beverage could be bitter. It could be frothy. It could contain spices. It could be mixed with water. And depending on the culture and period, cacao could be prepared in many different ways. The modern assumption that chocolate must be sweet would have seemed strange in many earlier cacao traditions. Sweetness became much more central to chocolate's identity later. One of the most fascinating features of ancient cacao preparation was the importance of foam. Foam was not simply an accidental result. People deliberately created froth by pouring the beverage between containers or otherwise aerating it. A foamy cacao drink could be considered especially desirable. The surface would become covered with bubbles, giving the beverage a texture and appearance very different from a modern cup of hot chocolate. Imagine the sound of liquid being poured from one vessel into another, a thin stream falling through the air, the liquid striking the container, tiny bubbles forming, a fragrant cacao drink becoming covered in foam. It is a remarkably simple technique, yet it shows how much attention people paid to the sensory qualities of cacao. The drink was not merely about nutrition. It was about experience. Cacao also had economic significance. In some Mesoamerican societies, cacao beans were used in trade and could function as a form of currency in certain contexts. This makes chocolate history particularly unusual. The same seed that could eventually become a delicious drink could also have economic value. A cacao bean was therefore more than an ingredient. It could represent wealth, trade, exchange, and access to desirable goods. Cacao's value was closely connected to the difficulty of producing it. The cacao tree requires specific environmental conditions. Growing the crop successfully requires knowledge and labor. The pods must be harvested. The seeds must be removed. They must be processed, and the resulting beans must be stored and transported. The ancient cacao economy, therefore, depended on agriculture, trade networks, and cultural knowledge. When we think about chocolate today, we usually think about taste. But cacao's history reminds us that food can also carry economic and social meaning. Different foods can become symbols of status. Cacao was one such food. Its rarity and desirability helped make it valuable. As cacao traditions developed, people experimented with flavor. Spices could be added. Chili peppers could provide heat. Other ingredients could change aroma and texture. Some traditional cacao beverages were therefore surprisingly complex. The flavor profile could combine bitterness, spice, acidity, and aromatic ingredients. This is very different from the familiar sweetness of modern milk chocolate. It also reminds us that there is no single correct way to enjoy cacao. Modern chocolate culture is only one chapter in a much longer story. For centuries, people have found different ways to work with the cacao seed. The ingredients may change. The preparation may change. The purpose may change. But cacao remains at the center. Eventually, cacao encountered Europeans. This changed its history dramatically. European explorers and colonizers encountered cacao in the Americas and eventually carried it across the Atlantic. At first, the unfamiliar flavor was not necessarily immediately beloved. The bitterness was very different from the sweet foods Europeans were accustomed to. But people began experimenting. Sugar was added. Spices were changed. Preparation methods evolved. And gradually, chocolate became increasingly popular. This is where the story begins moving toward the chocolate culture we recognize today. Sugar played an enormous role. Cacao and sugar form a particularly powerful combination. The bitterness of cacao can be softened by sweetness. At the same time, the complex aromas of cacao remain. This combination eventually helped transform chocolate from a bitter beverage into a broader family of sweet foods. Chocolate became associated with luxury. In European courts and wealthy households, cacao beverages could be consumed as fashionable drinks. Special equipment could be created for preparing and serving chocolate. Chocolate drinking became part of social life. Imagine a quiet 18th century room. Fine furniture, soft candlelight, a porcelain cup, a warm chocolate beverage, someone slowly stirring the drink. The atmosphere would be very different from someone grabbing a chocolate bar at a convenience store today. Chocolate was once a luxury consumed slowly. Its transformation into a mass-market food would take technological innovation. One of the most important developments involved separating cocoa solids from cocoa butter. This made it possible to produce cocoa powder. Cocoa powder could then be used in new ways. It could be mixed into beverages. It could become an ingredient in baked goods. And it could eventually contribute to the development of modern solid chocolate. The Industrial Revolution changed chocolate dramatically. Machines made it possible to process larger quantities of cacao. Production became more consistent. Chocolate became easier to manufacture. And as production costs fell, chocolate gradually became accessible to more people. The chocolate bar as we know it emerged from this long period of technological change. But there was still another major transformation ahead. Milk chocolate. Adding milk to chocolate created a softer, creamier, sweeter product. Milk chocolate became enormously popular. Its lighter color and smooth texture appealed to consumers who found darker chocolate too intense. Over time, milk chocolate became one of the dominant forms of chocolate around the world. But the story of milk chocolate is more complicated than simply adding milk to cacao. Milk contains water. Chocolate generally does not behave well when large amounts of water are introduced. So chocolate makers needed suitable methods for incorporating milk components. Milk powder and other dairy ingredients became important. This allowed manufacturers to create milk chocolate with the desired texture and stability. Chocolate chemistry became increasingly sophisticated. The industry learned how to control fat, moisture, particle size, temperature, crystal formation, mixing, and storage. The smooth chocolate bar that seems so simple today is actually a carefully engineered food. A good chocolate bar has a remarkable balance. It needs to be solid enough to hold its shape. It needs to break cleanly. It needs to melt smoothly. It needs to release aroma gradually. It needs to have particles small enough that the tongue does not perceive them as gritty. And it needs to remain stable during storage. These qualities require careful control. Chocolate is therefore an excellent example of food engineering. Even the shape of chocolate has been influenced by manufacturing. Bars are divided into sections. Squares make it easier to break pieces. Different shapes create different melting behaviors. Thin chocolate melts quickly. Thicker chocolate remains solid longer. A filled chocolate behaves differently from a solid chocolate. A truffle behaves differently from a bar. A chocolate coating behaves differently from chocolate used in baking. The physical structure of chocolate changes the experience. This is why chocolate is not simply a flavor. It is also a texture. And texture strongly influences our perception of food. Creaminess is one of the most important qualities associated with chocolate. But what exactly creates creaminess? Part of it comes from the small particle size. Part comes from fat. Part comes from how the chocolate melts. And part comes from how the brain interprets those sensations. When chocolate melts, cocoa butter spreads across the mouth. This contributes to the smooth sensation. Milk chocolate can feel especially creamy because of its combination of cocoa butter, milk components, sugar, and finely processed particles. Dark chocolate can also be exceptionally smooth when made well. The difference between smooth and gritty chocolate can be surprisingly noticeable. If you have ever tasted chocolate with a sandy texture, you have experienced what happens when particle size or processing is not ideal. Chocolate makers therefore devote enormous attention to refining. The goal is to reduce the size of solid particles until they become almost imperceptible. Your tongue is remarkably sensitive to texture. It can detect very small differences. That is why a chocolate that feels silky can seem dramatically more luxurious than one that feels coarse. The sensory experience is also affected by temperature. Chocolate served slightly warmer can release aromas more readily. Chocolate that is too cold may feel firmer and release less aroma at first. Chocolate that is too warm can become overly soft. Professional tasting therefore often involves controlling the environment. The chocolate may be allowed to warm gradually. A small piece may be placed on the tongue. Rather than immediately chewing it, a taster may allow it to melt. As it melts, different aromas and flavors can appear. The first impression might be sweetness, then roasted notes, then fruit, then bitterness, then perhaps a lingering nutty or earthy quality. The flavor can evolve over time. This is one reason high-quality chocolate is sometimes tasted slowly rather than eaten quickly. Chocolate is also highly aromatic. More than taste, smell contributes significantly to what we perceive as flavor. Before tasting chocolate, you can often smell it. Break a piece. Bring it near your nose. The aroma may already tell you something about what you are about to experience. This is especially noticeable with dark chocolate. The scent may be roasted, fruity, floral, nutty, spicy, earthy, or deeply cocoa-like. A chocolate bar can therefore be appreciated before it even touches your tongue. The human brain is exceptionally good at connecting aroma with memory. This may explain why the smell of chocolate can immediately remind someone of childhood. Perhaps it recalls baking with a family member. Perhaps it reminds someone of holidays. Perhaps it brings back the smell of a kitchen, or a birthday cake, or a warm drink on a winter evening. Chocolate can become linked to powerful memories because food and emotion are closely connected. This emotional connection is one reason chocolate is often given as a gift. A chocolate box can communicate celebration, affection, gratitude, apology, romance, or simply comfort. The object itself is small, but the cultural meaning surrounding it can be enormous. Chocolate has also become deeply connected with holidays. Halloween brings chocolate candies. Valentine's Day brings chocolate boxes. Easter brings chocolate eggs and rabbits. Christmas brings chocolate treats and desserts. Birthdays bring chocolate cakes. These traditions vary around the world, but the pattern is remarkably widespread. Chocolate has become a symbol of celebration, and perhaps part of its appeal is that chocolate feels indulgent. Even a small piece can feel like a special moment. That feeling is partly psychological. Chocolate contains sugar and fat, both of which are highly rewarding components of food. The combination can make chocolate especially appealing. But the sensory experience matters too. Sweetness, creaminess, aroma, melting, texture, temperature, all of these come together. The brain does not experience these properties separately. It combines them into a single pleasurable perception. Chocolate is therefore an excellent example of how sensory biology and food chemistry meet. But cacao itself contains naturally occurring compounds that make its chemistry particularly interesting. One of these is theobromine. Theobromine belongs to a group of compounds called methylxanthines. Caffeine is another member of the same broad chemical family. Theobromine is found naturally in cacao. Its concentration varies depending on the cacao product and processing. Dark chocolate generally contains more cacao solids than milk chocolate, so it may contain more theobromine. This is one reason chocolate is not recommended as a food for certain animals. Dogs, for example, metabolize theobromine differently from humans. What is a small treat for a person can be dangerous for a dog. This is why pet owners are advised to keep chocolate away from dogs. The risk depends on factors such as the type and amount of chocolate and the animal's size. The important point is simply that chocolate belongs in the human snack category, not the pet snack category. Cacao also contains caffeine, although typically in smaller quantities than many coffee beverages. The amount varies considerably depending on the chocolate. This means chocolate is not completely free of stimulants. However, the quantity in an ordinary serving can be much lower than in a typical cup of coffee. Chocolate's relationship with sleep is therefore more complicated than the simple idea that chocolate is either a sleep food or a wakefulness food. The type and amount matter. Dark chocolate can contain more cacao compounds than milk chocolate, and consuming a large amount of any rich food close to bedtime may not feel comfortable. For a sleepy documentary like this, though, We can simply appreciate the science without turning chocolate into a bedtime prescription. The cacao plant itself has another fascinating feature. It depends on pollinators. The flowers are tiny and specialized. Certain small insects, particularly tiny flies known as midges, play an important role in cacao pollination. This creates an unexpected connection between chocolate and tiny insects. Without successful pollination, cacao pods cannot develop. So every chocolate bar has a connection to an ecosystem that includes creatures most people never notice. A tiny insect visiting a tiny cacao flower may contribute to the beginning of a journey that eventually ends with chocolate thousands of kilometers away. It is a beautiful reminder of how interconnected ecosystems can be. The cacao tree does not exist alone. It participates in a network of organisms. Pollinators visit flowers. Other insects interact with leaves and fruit. Birds and mammals may interact with tropical ecosystems surrounding cacao. Farmers manage the trees, and humans eventually transform the harvested seeds. Chocolate is therefore the product of both biological and cultural networks. Another interesting feature of cacao is that not every pod looks the same. Different cacao varieties can produce different shapes, colors, sizes, and flavor characteristics. Historically, cacao has often been discussed in terms of broad groups such as Criollo, Forastero, and Trinitario. Modern cacao genetics are much more complicated than these three simple labels suggest. Researchers have identified many genetically distinct cacao populations. This diversity matters because genetics can influence flavor, disease resistance, yield, and other characteristics. The cacao tree, therefore, has a rich genetic story. Some varieties are prized for particular sensory qualities. Others are valued for productivity or resilience. Farmers and breeders must often balance these characteristics. A cacao tree producing excellent flavor but very low yields may have different economic importance from a tree that produces large quantities of beans. Agriculture is full of such trade-offs. Flavor is only one part of the equation. Disease resistance is another. Cacao can be affected by pests and diseases that threaten production. Plant diseases can spread through farms and regions, damaging pods and reducing harvests. This is one reason genetic diversity and agricultural research are important for the future of chocolate. The world wants chocolate, but chocolate depends on cacao, and cacao depends on healthy trees and healthy growing environments. That makes the future of chocolate closely connected with agricultural science. Climate is another concern. Cacao generally grows within a relatively narrow environmental range. Changes in temperature and rainfall can affect flowering, fruit development, and disease pressure. Farmers may need to adapt through shade management, irrigation where appropriate, improved planting material, soil management, or changes in farming practices. The chocolate industry, therefore, has an interest in climate resilience. A warmer world can change the conditions under which cacao grows. And because cacao production is concentrated in particular tropical regions, local climate changes can have global consequences. A drought in one region may affect harvests. A disease outbreak can reduce supply. A change in agricultural costs can influence prices. A change in supply can eventually influence the price of a chocolate bar in a distant supermarket. This is another hidden connection inside something as ordinary as a snack. The chocolate bar on a shelf is connected to global agriculture. It is connected to weather. It is connected to transportation. It is connected to energy. It is connected to labor. It is connected to manufacturing. And it is connected to consumer preferences. When millions of people suddenly want more of a particular kind of chocolate, the industry responds. When consumers become more interested in dark chocolate, premium cacao, organic farming, or sustainability, producers and manufacturers respond. Chocolate trends therefore influence agriculture. The relationship works in both directions. Agriculture shapes chocolate. Consumer demand shapes agriculture. And technology sits between them. Modern chocolate manufacturing can be extraordinarily precise. Factories may control temperature to very small margins. Machines can continuously mix chocolate. Sensors can monitor production. Automated systems can package enormous numbers of products. Yet the fundamental ingredient remains a seed from a tropical tree. That contrast is fascinating. A sophisticated modern factory can process cacao with incredible precision, but it still begins with something that grows quietly on a tree. Perhaps that is why chocolate feels both ancient and modern. Its origins are ancient. Its manufacturing can be extremely advanced. Its cultural meanings continue to evolve, and its future is still being written. There is also something wonderfully universal about chocolate. Although preferences differ, chocolate has become familiar in almost every part of the world. People who have never seen a cacao tree can recognize chocolate immediately. They may never have handled a raw cacao pod. They may never have smelled freshly fermented beans. They may never have watched cacao being roasted. Yet they know chocolate. This is the extraordinary reach of food culture. A tropical crop can become a global symbol, and a small seed can become a food known to billions of people. Now, as our journey continues, imagine returning once more to the cacao forest. The sun is beginning to lower. The heat of the afternoon is fading. Leaves move gently in the humid air. The cacao trees stand quietly beneath the taller canopy. Somewhere, a tiny midge moves among the flowers. A ripe cacao pod rests against the trunk. Inside it, the seeds wait. Nothing about the scene looks like a chocolate factory. There are no machines, no wrappers, no conveyor belts, no glossy advertisements. Only a tree, a fruit, and a forest. Yet hidden inside that fruit is the beginning of everything. The seed will eventually be fermented. It will dry. It will travel. It will roast. It will be ground. It will become part of chocolate. And someday, perhaps far away, someone will break a small piece from a bar. There will be a quiet snap. The chocolate will begin to melt. The aroma will rise. And for a few moments, an ancient tropical plant and a modern human life will meet in a single bite. That is the journey of chocolate, and we are only halfway into the story. So let your thoughts become quiet again. There is no need to remember everything we have explored. The names, places, processes, and scientific details can simply float by. You can let the words become background noise. The cacao forest is quiet. The leaves are moving. The air is warm. And somewhere beneath the trees, the cacao pods continue to grow. Slowly, patiently, naturally. And as you drift towards sleep, the story of chocolate continues waiting for us. In the next part, we will travel deeper into the strange chemistry of chocolate, explore how bitterness becomes sweetness, discover why chocolate melts the way it does, and uncover more of the hidden science behind the world's favorite cacao creations. For now, breathe slowly. Relax your face. Let your shoulders drop. And allow the story to fade gently into the quiet. If you are listening with your eyes closed, there is nothing you need to do. You do not need to memorize the details. You do not need to stay awake for the entire story. Let the words simply pass through your thoughts, one gentle idea at a time. We have already followed cacao from its tropical home into the hands of farmers, explored its ancient history, and watched the raw seeds slowly become the foundation of chocolate. Now we are going deeper. This time, we are entering the hidden world inside chocolate itself. A world of fats, sugars, aromas, crystals, acids, temperatures, and tiny molecules. Because chocolate may look simple, but inside that smooth surface is an extraordinary amount of chemistry. Take a small piece of chocolate and hold it in your hand. At first, it seems completely solid. It has a definite shape. Perhaps it is divided into squares. Perhaps it has a logo pressed into its surface. Perhaps it is wrapped in paper or foil. But chocolate is not truly motionless. At the microscopic level, its molecules are constantly moving. Even a solid chocolate bar contains energy. Its particles vibrate. Its fats exist in organized structures. Its sugar crystals form part of a complex, solid network. And its aroma compounds are waiting to escape. The moment you warm the chocolate, that structure begins to change. This is why chocolate is such an interesting material. It is solid enough to hold its shape, but it is also capable of becoming fluid with relatively gentle heating. The key to this behavior is cocoa butter. Cocoa butter is the main fat naturally found in cacao beans. It has a special combination of fatty acids that gives it unusual melting characteristics. Unlike some fats that remain solid over a broad range of temperatures, cocoa butter melts over a relatively narrow range. That helps give chocolate its distinctive behavior. At room temperature, properly formulated chocolate can remain firm. But as it approaches body temperature, the cocoa butter begins to melt. Inside your mouth, the transformation can happen quickly. A hard piece becomes soft, then creamy, then almost liquid. The solid chocolate seems to disappear. But technically, it has not disappeared. Its components have simply changed physical state and become dispersed through your mouth. That sensation is one of the defining pleasures of chocolate. The transition from solid to melted chocolate is remarkably smooth. And this is partly why chocolate is different from many other foods. Imagine chewing a piece of hard candy. It may become smaller. It may dissolve slowly. But chocolate can seem to collapse almost effortlessly. The cocoa butter melts. The particles become suspended. The texture changes. Aroma is released. And the experience becomes increasingly fluid. This is also why chocolate can behave differently depending on the temperature of the room. A cool room may leave a chocolate bar firm. A warm room may make it soft. A very hot environment can cause it to melt completely. The chocolate does not have to be cooked to change. Ordinary environmental heat is enough. This sensitivity makes chocolate manufacturing particularly demanding. Chocolate makers must control temperature carefully. One of the most important concepts is crystal structure. Cocoa butter can form different types of crystals. These structures are not all equally desirable. Some produce chocolate that is soft. Some produce chocolate that melts differently. Some can create a dull surface. Others produce the smooth appearance and satisfying snap that people expect from high-quality chocolate. The goal of tempering is to encourage the formation of a desirable cocoa butter crystal structure. Tempering involves carefully heating and cooling chocolate. The exact temperatures depend on the type of chocolate and formulation. Dark, milk, and white chocolates do not necessarily follow identical temperature curves. A chocolatier may melt the chocolate, cool it, and then warm it again within a carefully controlled range. This sounds simple, but the process requires precision. A few degrees can make a significant difference. That is why professional chocolate makers often work with thermometers and temperature-controlled equipment. The final product depends on controlling microscopic structures that cannot be seen directly. And when tempering works properly, the result is visible. The chocolate can have a glossy surface. It can break with a crisp snap. It can feel smooth. And it can melt predictably in the mouth. This is an example of something tiny influencing something we experience every day. The structure of microscopic fat crystals becomes the sound of a chocolate bar breaking. It becomes the shine on the surface. It becomes the texture against the tongue. And it becomes part of the reason chocolate feels luxurious. There is another fascinating part of chocolate chemistry: sugar. Sugar crystals are much larger than the particles involved in the smoothest chocolates. Chocolate makers therefore work hard to control particle size. Imagine grinding something until the individual pieces become so tiny that your tongue can barely distinguish them. That is essentially what happens during chocolate refining. Cacao particles and sugar particles are reduced to very small sizes. The smoother the chocolate, the less noticeable these particles become. Your tongue is incredibly sensitive to roughness. Even tiny differences can be detected. This is why chocolate with insufficient refining can feel sandy. The flavor may be perfectly acceptable, but the texture can immediately reveal the difference. Modern chocolate makers therefore use specialized equipment to grind and refine ingredients. The process can take considerable time. Chocolate is repeatedly processed until the desired particle size and texture are reached. The goal is not simply to make chocolate smaller. It is to make it feel smooth. That distinction matters. The chocolate must still contain solid particles. But those particles need to be small enough that the mouth interprets the texture as creamy rather than gritty. Creaminess itself is an interesting sensory illusion. There is no single creaminess molecule. Instead, your brain receives many signals. The fat melts. The particles become dispersed. The chocolate spreads across the tongue. The temperature changes. The aroma develops. And the brain interprets all of these sensations together. The result is what we describe as smoothness or creaminess. This is why chocolate is such a useful example of multisensory perception. Taste alone cannot explain the experience. Smell alone cannot explain it. Touch alone cannot explain it. Temperature alone cannot explain it. The experience comes from all of them working together. Now think about bitterness. Cacao naturally contains bitter compounds. This is one reason raw cacao does not taste like a sweet chocolate bar. The bitterness is partly associated with compounds found naturally in cacao, but processing can change how those compounds are perceived. Fermentation, roasting, and other stages influence the final flavor. Sugar can also balance bitterness. This is one reason dark chocolate can taste very different depending on its formulation. A chocolate with a high cacao percentage may contain less sugar. That does not automatically mean it will taste unpleasant. Instead, the cacao flavors become more prominent. Some people experience these flavors as intensely bitter. Others notice fruit, nuts, flowers, spices, or roasted notes. Taste perception varies between individuals. Our sensitivity to bitterness is partly influenced by genetics. Some people are more sensitive to certain bitter compounds than others. This means that two people can eat the same chocolate and experience it differently. One person may say it tastes wonderfully complex. Another may say it is overwhelmingly bitter. Neither person is necessarily wrong. Their sensory systems are different. The same principle applies to sweetness. People vary in their preference for sweet foods. Chocolate manufacturers therefore formulate products for different audiences. Some chocolates contain considerable amounts of sugar. Others use much less. Some emphasize cacao. Others emphasize milk. Some emphasize fillings. Others emphasize pure chocolate flavor. The diversity of chocolate products is partly a reflection of the diversity of human taste. And chocolate itself can be surprisingly complex even when it contains only a few ingredients. A simple dark chocolate may contain cacao, sugar, and perhaps a small amount of additional ingredients. Yet it can contain hundreds of flavor compounds. Not all of these compounds contribute equally. Some are present in tiny amounts, but together they create a distinctive aroma. This is one reason chocolate flavor is difficult to reproduce artificially. A simple description like chocolate flavor hides an enormous chemical mixture. The aroma of roasted cacao is created through many reactions. One important family of reactions involved in roasted foods is the Maillard reaction. The Maillard reaction occurs when certain amino compounds and reducing sugars react under heat. It contributes to browning and the development of many roasted aromas. You encounter related chemistry when bread develops a golden crust, coffee becomes aromatic during roasting, or meat browns during cooking. Cacao roasting involves its own complex set of reactions. Heat changes the chemistry of the beans. New compounds form. Others break down. Volatile molecules are released, and the aroma becomes increasingly recognizable. The raw cacao seed is therefore chemically very different from the roasted bean. Roasting is not simply drying the bean again. It is a transformation. This is why raw cacao and roasted cacao can taste so different. The process has created a new flavor landscape. But roasting requires balance. Too little roasting may leave undesirable flavors. Too much can create burnt or harsh notes. Chocolate makers therefore adjust roasting conditions based on the cacao. Different beans may respond differently. The desired flavor profile also matters. A chocolate maker seeking delicate fruity notes may roast differently from one seeking intense roasted characteristics. This is where chocolate production becomes partly artistic. Science provides the tools, but human judgment determines the desired result. The same cacao can potentially be processed in different ways to emphasize different characteristics. Temperature, time, airflow, grinding, conching, formulation, all can influence the final product. And because cacao varies naturally from harvest to harvest, chocolate making is not always perfectly predictable. Agricultural products are never completely identical. A cacao harvest from one year may differ from the next. Rainfall may have changed. Temperature may have changed. The timing of harvest may differ. Fermentation may have developed differently. Even neighboring farms can produce cacao with different characteristics. This is part of what makes fine chocolate interesting. A chocolate bar can carry a sense of place. The idea is similar to coffee or wine. The environment where the crop grows can influence the final sensory experience. Soil, climate, elevation, shade, genetics, fermentation, roasting, all can contribute. Chocolate therefore has something resembling a geographical personality. A cacao from one region may taste fruity and bright. Another may taste earthy and deep. Another may have floral characteristics. Another may have nutty or caramel-like notes. These differences are not simply imagination. They can arise from real differences in chemistry and processing. Professional chocolate makers sometimes purchase cacao from specific regions because they want particular flavor characteristics. This has encouraged the growth of craft and specialty chocolate. Small chocolate makers may focus on traceable cacao. They may want to know where the beans came from. They may work closely with farmers or cooperatives. They may roast small batches, and they may try to preserve distinctive characteristics of the cacao. This approach is very different from producing enormous quantities of standardized chocolate. Both systems have their place. Mass-produced chocolate emphasizes consistency and affordability. Craft chocolate may emphasize origin, flavor complexity, and small batch processing. Neither approach changes the fundamental journey from cacao seed to chocolate, but the priorities can be different. Another interesting aspect is the role of cocoa butter in chocolate texture. Chocolate contains both fat and solid particles. The way those components are distributed is crucial. If the cocoa butter does not surround the particles properly, the chocolate may not flow or melt as intended. Manufacturers therefore carefully control mixing and refining. Some chocolate also contains additional fats, depending on the product and regulations. Different fats can change melting behavior. This is one reason chocolate substitutes may feel different from traditional chocolate. The fat composition matters. The melting profile matters. And the sensory experience depends on both. Now consider what happens when chocolate is melted and then cooled incorrectly. Perhaps you have seen a chocolate bar that develops pale streaks or cloudy patches. This is often called bloom. Fat bloom occurs when cocoa butter or other fats move through the chocolate and form new crystals on the surface. The chocolate may appear grayish or whitish. Sugar bloom is different. It can occur when moisture interacts with sugar. The sugar dissolves and then recrystallizes. The surface may become rough. Both forms of bloom can affect appearance and texture. They are reminders that chocolate is not a chemically frozen object. Its structure can continue changing during storage. Temperature fluctuations are especially important. Imagine a chocolate bar sitting in a warm car. It begins to soften. Later, the car cools. The chocolate solidifies again. That cycle can encourage structural changes. The chocolate may still be edible, but its appearance or texture may no longer be ideal. This is why stable storage conditions are important. Chocolate generally prefers a cool, dry environment away from strong odors and major temperature swings. The refrigerator can be useful in certain circumstances, but it can also introduce moisture and odors. If chocolate is refrigerated carelessly, condensation can appear when it is removed. That moisture can contribute to sugar bloom. So even storing chocolate can become a small scientific experiment. Temperature, humidity, packaging, time, all matter. The packaging itself is important. Chocolate can absorb odors from its environment. If chocolate is stored near strongly scented foods, some aroma compounds can migrate or interact with the chocolate. Because chocolate contains fat, it can be particularly good at holding on to certain aromas. This can be wonderful when the aroma is intentional. It can be unpleasant when the aroma comes from something you did not want your chocolate to taste like. Chocolate makers therefore use packaging to protect the product. Good packaging helps limit exposure to moisture, oxygen, light, and unwanted odors. Light can also contribute to deterioration over time. Chocolate is not immortal. Even when stored properly, it can change. The flavor may become less fresh. Aromas may fade. Fats can oxidize. The product can gradually lose some of its original character. This is why chocolate has a best before date. But chocolate's shelf life can be quite long compared with many fresh foods, particularly when stored properly. Its relatively low water content helps. Microorganisms generally need available water to grow. Chocolate is not a particularly hospitable environment for many microbes. But low moisture does not mean chocolate is completely protected from all forms of deterioration. Fat oxidation remains possible. Storage conditions still matter. Another surprising part of chocolate chemistry is the relationship between cacao and acidity. Fermentation produces acids. Some of these acids can remain in the beans if processing is not sufficient to reduce them. Roasting can help transform or remove certain volatile acids. Conching can also influence flavor. A chocolate maker may therefore use multiple stages to reduce undesirable acidic characteristics. The final chocolate should have balance. Too much acidity can be harsh. Too much bitterness can overwhelm. Too much sweetness can hide cacao flavors. Too much roast can create burnt notes. The best chocolate is often about balance rather than maximum intensity. This is why chocolate tasting can be surprisingly similar to tasting coffee or wine. People may talk about acidity, bitterness, body, aroma, finish, texture, origin, and balance. A chocolate can have a short finish, where the flavor disappears quickly. Another can have a long finish, where the flavor remains for a considerable time. The finish is partly influenced by fat, aromatic compounds, and the composition of the chocolate. A chocolate with a rich cocoa butter content may coat the mouth and carry aromas for longer. The experience continues after the bite. This is why some people allow chocolate to melt rather than chewing immediately. The melting process gradually releases different sensations. At first, the chocolate may seem firm. Then the outer layer softens. The aroma becomes stronger. The chocolate spreads. Sweetness becomes more noticeable. Bitterness may appear. Then the flavor begins to fade. A slow tasting can reveal stages that disappear if the chocolate is eaten quickly. This does not mean that slow tasting is the correct way to eat chocolate. Sometimes a chocolate bar is simply a snack. But slowing down can reveal how complex an ordinary food can be. Now imagine a single cacao bean. It may look small, perhaps no larger than a fingernail. But inside that seed is a complicated mixture of fats, carbohydrates, proteins, minerals, fiber, polyphenol, alkaloids, and flavor precursors. It is a tiny biochemical package. During fermentation, many of those components interact. During roasting, they transform. During grinding, their physical arrangement changes. During conching, the flavor evolves. During tempering, the fat structure becomes organized. And finally, during eating, the entire structure changes again. The cacao bean therefore experiences multiple transformations. Biological transformation, chemical transformation, mechanical transformation, thermal transformation, and sensory transformation. This is what makes chocolate such a fascinating food. It is not merely a recipe. It is a sequence of transformations. One stage prepares the material for the next. Fermentation prepares the beans for flavor development. Drying prepares them for storage. Roasting develops aroma. Grinding releases cocoa butter. Refining improves texture. Conching influences flavor and consistency. Tempering controls crystal structure. Packaging protects the final product. And then your body completes the final transformation. Chocolate enters the mouth. Heat changes it. Saliva interacts with it. Mechanical movement breaks it down. Digestive processes take over. The food that began as a cacao seed has now become part of a completely different biological system. There is something almost poetic about that journey. A tree absorbs sunlight. It grows leaves. It produces flowers. A tiny insect helps pollinate one. A pod develops. Seeds form inside. Humans harvest them. Microorganisms ferment them. Sunlight dries them. Heat roasts them. Machines grind them. People shape them. And eventually, a person eats them. The journey crosses forests, farms, factories, stores, kitchens, and finally the human body. All of that from one small seed. And yet, Chocolate's story contains another fascinating subject: its relationship with human emotions. Chocolate has become associated with happiness, comfort, reward, romance, and celebration. People often describe craving chocolate, but cravings are complicated. They can involve learned associations, sensory cues, hunger, habits, emotions, and the rewarding combination of sugar and fat. The smell of chocolate can trigger anticipation. Seeing chocolate can trigger memories. Even imagining chocolate can make someone think about its taste. The brain can begin preparing for food before it enters the mouth. This is why advertisements often focus heavily on texture and sensory imagery. A slow stream of melted chocolate, a crisp break, a creamy filling, a shiny surface. These images activate expectations, and expectations influence perception. If you believe a food will taste luxurious, your brain may interpret its sensory signals partly through that expectation. Chocolate is therefore not only chemistry. It is psychology. It is memory. It is culture. It is biology. And it is agriculture. All of these layers overlap. Perhaps that is why chocolate has survived so many centuries of cultural change. People keep finding new ways to use it. Ancient cacao beverages, European drinking chocolate, modern chocolate bars, chocolate pastries, cakes, cookies, ice cream, truffles, sauces, cereals, protein snacks, hot drinks. The possibilities seem almost endless. Chocolate can be solid, liquid, frozen, whipped, baked, coated, filled, shaved, grated, melted, and molded into almost any shape. Its versatility comes from its physical and chemical properties. Cocoa butter can melt and solidify. Cocoa solids provide deep color and flavor. Sugar provides sweetness and structure. Milk components provide creaminess. Together, they create a remarkably adaptable ingredient. This adaptability has made chocolate a favorite of professional pastry chefs. A pastry chef can use chocolate for structure, decoration, flavor, texture, and contrast. A thin chocolate shell can surround a soft filling. Chocolate can be used to create delicate decorations. It can be shaved over desserts. It can be folded into creams. It can be incorporated into dough. It can become a sauce. And it can even be used in savory cooking. Although sweet chocolate dominates modern culture, cacao has long had relationships with savory flavors. Chili and cacao have historical connections. Spices can complement chocolate. Salt can intensify sweetness and balance bitterness. Coffee can deepen roasted notes. Nuts can provide contrasting texture. Fruit can add acidity. These combinations work partly because flavor is about contrast as well as similarity. Sweetness can be balanced by bitterness. Fat can be balanced by acidity. Softness can be balanced by crunch. Chocolate becomes a canvas, and humans keep painting new flavors onto it. As our sleepy journey moves forward, it is worth remembering the tiny cacao flower. It may be easy to overlook. It is small. It is delicate. It is nowhere near as visually impressive as the finished chocolate products it ultimately makes possible. But without the flower, there is no pod. Without the pod, there are no seeds. Without the seeds, there is no cacao. Without cacao, there is no chocolate. The entire global chocolate industry ultimately depends on a biological process occurring in tiny flowers on tropical trees. That is perhaps one of the most beautiful facts of all. The world's chocolate supply begins quietly. No factory lights, no machines, no advertisements, just a small flower, a tiny pollinator, a growing pod, and time. So as you settle down tonight, imagine that tropical forest once more. The air is warm, The trees are still. Leaves rustle softly. A cacao pod hangs from the trunk. Inside are rows of seeds surrounded by sweet pulp. The future chocolate is still invisible. Nothing looks like a chocolate bar yet, but the possibility is already there. The forest is the beginning. The factory is much later. The wrapper is much later. The chocolate square is much later. The bite is much later. For now, there is only the tree, and perhaps that is where we should leave our thoughts for a moment. At the beginning, at the quiet place where chocolate starts. As the forest grows darker, the temperature slowly falls. The leaves continue moving. The cacao tree stands quietly. And somewhere inside a distant factory, another batch of chocolate may be cooling into its final shape. From forest to factory, from seed to chocolate, from chemistry to sensation, the journey continues. You can let your eyes become heavier now. There is nothing else you need to do. Simply breathe, slowly, quietly, and let the chocolate story continue in the background. In the next chapter, we will explore even more surprising sides of chocolate, including its connection with health, animals, culture, famous inventions, unusual chocolate traditions, and the remarkable ways humans have learned to transform cacao. Until then, rest comfortably. Let your thoughts soften. Let the story become distant. And perhaps, somewhere in your imagination, a cacao forest is quietly growing beneath the stars. And welcome to another peaceful night with Sleepy Discovery. By now, we have traveled from tropical cacao forests to ancient civilizations, from tiny flowers to colorful cacao pods, and from fermented seeds to the smooth chocolate that eventually reaches our hands. But there are still many gentle mysteries to explore. Chocolate is more than a sweet food. It is a plant, a crop, a chemical mixture, a cultural tradition, a manufacturing achievement, a source of memories, and, in many parts of the world, a small, everyday pleasure. So let yourself become comfortable. You do not need to keep track of where we are. You do not need to remember every detail. Simply allow the story to move slowly. Tonight, we will explore some of the more surprising connections surrounding chocolate. And perhaps the first surprising connection is with health. Chocolate has been studied by scientists for many years. Researchers have been particularly interested in cacao because it contains naturally occurring compounds called flavonols and other polyphenols. These compounds are part of the plant's natural chemistry. They are also found in many other plant foods. Cacao is unusual because some of its polyphenol can remain present in processed products, although the amount can vary greatly depending on how the cacao is processed and what other ingredients are added. This is where the distinction between cacao and chocolate becomes important. A cacao bean is not the same thing as a chocolate candy bar. The nutritional composition of a chocolate product depends on everything that goes into it. Dark chocolate may contain a relatively high proportion of cacao. Milk chocolate contains milk ingredients and usually more sugar. White chocolate contains cocoa butter but generally lacks the cocoa solids that provide much of cacao's characteristic flavor and many of its naturally occurring plant compounds. So when scientists study cacao, it is important not to automatically assume that every chocolate product has the same properties. The food itself can vary dramatically. This is one reason nutrition research can sometimes sound confusing. A study may examine a specific cacao extract or a particular high cacao product. That does not mean that eating unlimited amounts of ordinary chocolate produces the same result. Food is complicated. Dose matters. Composition matters. And the entire diet matters. Cacao also contains minerals. Among them are magnesium, iron, copper, and manganese. Although the amounts available to the body depend on the product and serving size. Dark chocolate can contain more of certain minerals because it contains more cacao solids. But chocolate is also energy dense. It contains fat and, depending on the product, significant amounts of sugar. This means chocolate can fit into a balanced diet, but portion size remains important. A small amount and a large amount are very different nutritional experiences. The same principle applies to many foods. A handful of nuts is different from eating an entire jar. A small dessert is different from consuming a huge portion. Chocolate is simply particularly easy to overeat because it combines appealing flavors and textures. There is another interesting part of chocolate's chemistry. Cocoa contains theobromine. Theobromine is related to caffeine and belongs to the methylxanthine family. It has been studied for its effects on the human body. It is one reason cacao is chemically different from many other foods. Chocolate also contains small amounts of caffeine. The amount depends on the product and cacao content. Dark chocolate generally contains more caffeine than products with less cacao, although the amount is still usually much lower than in coffee. For most people, a moderate serving of chocolate is not equivalent to drinking a strong cup of coffee. But sensitive individuals may still notice the effects of caffeine and other compounds. This is one reason some people prefer not to eat large amounts of dark chocolate immediately before sleep. And yet, chocolate has an interesting relationship with sleep. People often associate chocolate with relaxation and comfort. A warm cup of cocoa can feel soothing. The ritual itself can be calming. But the physiological effects of chocolate depend on the type and quantity consumed. So chocolate should not be thought of as a guaranteed sleep aid. The peaceful feeling may come partly from routine, warmth, memory, and comfort rather than chocolate acting like a sleep medicine. That distinction is important. Food can influence mood and experience without functioning as medicine. Chocolate has also been investigated in relation to the cardiovascular system. Some research on cacao flavonols has explored effects on blood vessel function. The findings have generated interest because cacao contains compounds that can interact with biological pathways involved in circulation. But again, the details matter. The research does not mean that chocolate is a magical treatment for heart disease. Chocolate products vary enormously. A high cacao product with relatively little sugar is chemically different from a heavily sweetened candy. And research on isolated compounds or controlled amounts cannot always be directly translated into everyday eating habits. Science often moves slowly. It asks specific questions. It tests specific amounts. And it examines specific populations. That is why a headline saying, "Chocolate is good for you," can be misleading if it removes all the context. The truth is usually more interesting. Cacao contains biologically active compounds. Chocolate can be part of a balanced diet. Different products have different nutritional profiles, and moderation remains important. The story of chocolate and health is therefore not a simple story of good or bad. It is a story of chemistry, quantity, context, and individual differences. There is another interesting health-related characteristic of cacao. Its bitterness is not an accident. Plants produce many compounds as part of their natural defenses. Some of these compounds can discourage animals from eating them. Cacao's bitter chemistry may therefore have ecological significance. The cacao seed is not simply a sweet food waiting to be eaten. It is part of a plant reproductive system. The tree produces fruit containing seeds. Animals interact with the fruit. Humans have learned to harvest and transform the seeds. The relationship between plants and animals is complicated. Some animals may consume parts of cacao fruit. Others may interact with the surrounding ecosystem. But humans have taken cacao in a completely different direction. Instead of simply eating the fruit, we process the seeds into a globally important ingredient. The cacao pod itself is also fascinating. A mature pod can be surprisingly large compared with the tiny flowers from which it developed. The transformation is gradual. A tiny flower becomes a developing fruit. The pod grows. Its color changes. Its seeds develop inside. Eventually, it is ready for harvest. The contrast between flower and fruit is remarkable. A tiny structure on the trunk eventually becomes a pod filled with dozens of seeds. Those seeds may then begin another biological process when they are fermented. Fermentation is one of the most important transformations in the entire cacao journey. The pulp surrounding the beans contains sugars. Microorganisms consume these sugars. Different microbial populations become active at different stages. Heat builds. The chemistry changes. And compounds that will later contribute to chocolate flavor begin to develop. The fermentation process can vary. Some producers use wooden boxes. Others use heaps or baskets. The beans may be covered with leaves or other materials. They may be turned periodically. The method depends on local traditions, climate, farm size, and available resources. There is no single universal fermentation system. This variation is another reason cacao from different farms can taste different. The beans may come from similar genetic backgrounds, yet their processing environments can produce different results. Once fermentation is complete, the beans must be dried. Drying is essential. If too much moisture remains, storage problems can develop. Proper drying helps stabilize the beans for transportation and storage. Traditional sun drying can take place on raised platforms, mats, patios, or other surfaces. The image is peaceful. Warm sunlight, brown cacao beans, a gentle breeze, farmers turning the beans, the aroma of tropical vegetation in the air. It is a quiet stage of chocolate production. But even this simple step requires care. Beans must dry evenly. They must be protected from rain. They must be monitored for contamination. And they must eventually reach an appropriate moisture level. Agriculture often looks simple from a distance. Up close, it is full of decisions. A farmer is constantly responding to weather, plants, soil, insects, disease, and timing. Cacao farming is no different. And behind every chocolate product is agricultural labor that consumers rarely see. This is especially important because cacao production is often associated with smallholder farmers. Many farms are relatively small. Farmers may grow cacao alongside other crops. They may depend on cacao as one part of their household income. The price they receive for cacao can be influenced by international markets. This creates a complicated relationship between global chocolate demand and local agricultural livelihoods. When consumers buy chocolate, the money does not travel directly from the store to one farmer. There are many steps. Farmers sell cacao. Cacao may move through cooperatives, local buyers, exporters, processors, manufacturers, distributors, and retailers. Each stage adds value and cost. This long supply chain is one reason conversations about sustainable chocolate can become complicated. People want farmers to receive fair compensation. They want forests protected. They want working conditions improved. They want cacao production to be environmentally responsible. But achieving all of these goals requires cooperation across many parts of the industry. Certification programs are one approach. Some chocolate products carry labels associated with environmental or social standards. But certification systems differ. A label can indicate that certain requirements have been met, but it does not automatically tell the entire story of a supply chain. Consumers interested in sustainability often look for additional information about sourcing and company practices. The chocolate industry has been working on traceability, farmer support, agroforestry, productivity, and other approaches. There is still much work to do. The future of chocolate depends not only on delicious recipes, but on healthy cacao-growing communities and ecosystems. This brings us back to forests. Cacao can be grown in agroforestry systems where trees provide shade. Shade can help moderate temperatures. It can create habitat. It can support greater biodiversity than some intensive agricultural systems. But cacao farming practices vary widely. Not every cacao farm is an agroforest. Not every shade system provides the same ecological benefits. And not every agricultural landscape is equally sustainable. The important point is that cacao and forests can be closely connected. The future of chocolate is therefore partly a story about land management. Healthy soil, healthy trees, water, biodiversity, pollinators, climate, and farmer knowledge. The tiny cacao flower introduces another remarkable ecological connection. Its pollination depends heavily on small insects. The cacao flower is not designed for giant bees or colorful butterflies. Its pollination is associated particularly with tiny flies called midges. These insects are so small that many people would never notice them. Yet they can play an important role in the cacao life cycle. Imagine the scale difference. A human being eats a chocolate bar. The chocolate bar comes from cacao. The cacao comes from a pod. The pod comes from a flower. The flower may be pollinated by an insect smaller than a grain of rice. That means something almost invisible can contribute to something that is globally recognized. This is a wonderful reminder that ecosystems do not operate according to human scale. The smallest organisms can influence enormous systems. There are also many other organisms associated with cacao ecosystems. Birds, insects, fungi, microorganisms, trees, vines, soil organisms. Each occupies its own place. Cacao farming can therefore become part of a broader ecological network. The science of cacao does not stop at chemistry. It extends into ecology. And then there is genetics. Modern researchers can examine cacao DNA to understand relationships among varieties and populations. This helps scientists investigate disease resistance, flavor traits, productivity, and adaptation. The genetic diversity of cacao is important because the industry depends on a relatively limited number of cultivated populations compared with the enormous diversity found in wild cacao. Wild cacao populations can contain useful genetic traits. Some may have resistance to diseases. Others may have different flavor characteristics. Others may tolerate environmental stresses. Conserving genetic diversity can therefore help protect the future of the crop. This is another hidden reason why tropical forests matter. Wild relatives of important crops can contain genetic information that may become valuable in the future. The forest is not simply a source of today's cacao. It can be a library of possibilities for tomorrow. Chocolate, therefore, has a connection with biodiversity conservation. When we protect plant diversity, we protect options for future agriculture. And cacao is one example of this larger principle. The cacao tree itself belongs to the plant family Malvaceae. This family includes many familiar plants, although the cacao tree has its own unique characteristics. Its flowers, fruits, and seeds have evolved over long periods. The relationship between cacao and humans is much more recent in comparison with the age of the plant lineage. Humans did not create cacao. We discovered its usefulness. Then we selectively cultivated it. We developed techniques to process it. We carried it across continents. And eventually, we transformed it into a global commodity. This is a recurring pattern in human history. A wild plant becomes a crop becomes a trade good becomes an industry, and an industry becomes part of everyday life. Chocolate followed this path remarkably well. The history of cacao also demonstrates how food can travel across cultures. Ancient American cacao traditions influenced European chocolate. Europe then developed its own chocolate traditions. Those traditions spread further around the world. Today, chocolate can be found almost everywhere. The journey was not simple. It involved exploration, colonization, trade, agriculture, technology, and cultural exchange. Some parts of chocolate's history are beautiful. Others are deeply complicated. The global cacao trade became connected with systems of exploitation and forced labor during different historical periods. Chocolate's luxurious reputation therefore exists alongside difficult questions about how cacao was produced and who benefited from its trade. Understanding chocolate history means acknowledging both sides. The food itself can be comforting, but its history is not always comfortable. The modern chocolate industry continues to face concerns about labor practices and child labor in cacao-producing regions. This is why responsible sourcing matters. Consumers may never see the farms where their chocolate begins, but the people working there are an essential part of the story. A chocolate bar cannot exist without farmers. This is easy to forget when chocolate appears as a finished product. Packaging can hide the agricultural origin. A polished wrapper can make the food feel like a manufactured object rather than an agricultural crop. But chocolate remains a farm product. Just like coffee, just like tea, just like bananas, just like wheat. The difference is that cacao undergoes an especially long transformation before reaching consumers. A wheat grain can still be recognized in flour. A coffee bean is roasted and ground, but its origin remains somewhat recognizable. Cacao beans become something dramatically different. A fermented seed becomes a smooth brown confection. The original plant almost disappears. Only the flavor remains. This makes chocolate a particularly powerful example of food transformation. There is another transformation that happens before chocolate is even made. The cacao bean must be roasted. Roasting changes color. Raw cacao beans can have purplish or brownish internal colors depending on variety and processing. After roasting, the beans become darker. Aromatic compounds develop. The familiar roasted cacao smell begins to appear. This is why walking into a chocolate factory or specialty chocolate workshop can be such a powerful sensory experience. The aroma can be enormous. Chocolate aromas can fill a room. They can linger in the air. They can create an immediate association with sweetness even before you taste anything. Smell is powerful because the olfactory system is closely connected with areas of the brain involved in memory and emotion. A chocolate aroma can therefore trigger memories surprisingly quickly. Perhaps a childhood kitchen, perhaps a holiday, perhaps a particular person, perhaps a warm drink on a cold evening. This is not unique to chocolate, but chocolate has an especially strong cultural association with comfort. Another reason chocolate can feel comforting is its texture. Creaminess is often associated with richness. Smooth textures can be perceived as pleasurable, and chocolate combines creaminess with aroma and sweetness. This creates a particularly strong sensory package. The brain receives multiple signals that all point towards something rewarding. This is one reason chocolate is frequently used in desserts. It pairs well with other rich ingredients: cream, butter, milk, nuts, caramel, vanilla, coffee, fruit, salt, spices, even chili. Chocolate's flavor profile is broad enough to work with many different ingredients. Dark chocolate can provide bitterness and depth. Milk chocolate can provide sweetness and creaminess. White chocolate can provide cocoa butter richness and sweetness. Different forms, therefore, play different culinary roles. Chocolate can also create contrast. A dark chocolate shell around a soft filling. A crunchy nut inside creamy chocolate. A cold ice cream covered with warm chocolate sauce. A bitter cocoa powder sprinkled over sweet cream. A pinch of salt over a sweet chocolate dessert. Contrast makes food interesting. Chocolate is particularly good at carrying contrasting flavors because its own flavor is complex enough to support them. There is also something called the mouth-feel of chocolate. Mouth-feel includes physical sensations that are not exactly taste. Creaminess, astringency, thickness, coating, melting behavior, temperature. These characteristics influence how chocolate feels in the mouth. Cacao polyphenol can contribute to astringency. Astringency is the drying or puckering sensation sometimes associated with certain foods and drinks. Tea and red wine can also create astringent sensations. In chocolate, the balance between astringency, bitterness, sweetness, and fat can influence the overall experience. This is another reason processing matters. Fermentation and roasting can influence the balance of compounds that contribute to these sensations. Chocolate making, therefore, involves managing not just flavor, but physical sensation. And this is where the art of tasting becomes interesting. A professional taster may evaluate the chocolate before eating it. They may look at the surface. Is it glossy? Is it uniform? Does it show bloom? Then they may listen. Does it snap cleanly? Then smell. What aromas are present? Then taste. How quickly does it melt? What flavors appear? How long does the finish last? What is the balance between sweetness and bitterness? Does the texture feel smooth? Is there any astringency? These questions turn a simple snack into an analytical experience. But you do not need to become a professional taster. You can simply notice. The next time you eat chocolate, perhaps take a moment before the first bite. Look at it, smell it, break it, listen, then allow it to melt. You may discover details that were always there, but previously moved too quickly to notice. This slower approach can also make a small amount feel more satisfying. When attention increases, the brain can extract more information from the experience. The food becomes an event rather than background noise. And perhaps that is a fitting idea for a sleepy documentary. We spend so much of the day moving quickly, eating quickly, working quickly, scrolling quickly, speaking quickly. Chocolate, at least occasionally, can be experienced slowly. One small piece, one quiet moment, one aroma, one taste, then it is gone. There is something almost meditative about that. Of course, not every chocolate experience is peaceful. Chocolate is also part of celebrations, advertisements, crowded stores, birthday parties, and holiday gatherings. It can be energetic. It can be playful. It can be extravagant. But beneath all those cultural layers remains the same cacao tree. A tree that prefers warm tropical conditions. A tree with small flowers. A tree producing colorful pods. A tree whose seeds eventually become chocolate. That tree has no idea what a chocolate bar is. It simply grows. And perhaps that is where we can return as the night becomes quieter. The forest, the tree, the pod, the seed, the slow process. Imagine a cacao farm at sunset. The air has cooled slightly. The leaves are darker now. The shadows are long. Cacao pods hang quietly from trunks. The farm is beginning to settle. The insects become more active as the temperature changes. The sounds of the forest grow deeper. Somewhere, a farmer has finished the day's work. Somewhere else, beans are drying. Somewhere far away, a chocolate factory is preparing another batch. The same crop connects all of these places. Forest, farm, factory, kitchen, store, home, and finally you. A tiny seed has traveled through all of them. That journey is extraordinary when you slow down enough to notice it. Chocolate is not just something we eat. It is something we inherit from landscapes, cultures, technologies, and generations of human experimentation. And yet, after all that complexity, the final moment can be beautifully simple. You hold a piece. You take a bite. It melts. And for a few seconds, everything else can become quiet. So let yourself become quiet now. There is nothing more you need to remember. The cacao tree is still growing. The forest is still breathing. The chocolate is still resting. And the story is still moving forward. In our final chapter, we will bring together even more remarkable pieces of the chocolate story, exploring unusual varieties, chocolate traditions around the world, surprising records, the future of cacao, and the many little details that make chocolate such an extraordinary part of human life. Until then, let the day become distant. Slow your breathing, relax your shoulders, allow your thoughts to soften, and imagine the warm tropical forest fading slowly beneath a quiet night sky. The cacao leaves move gently in the breeze. The pods hang peacefully from the trees. And somewhere inside those pods are tiny seeds carrying a story that has traveled across centuries. A story that eventually becomes chocolate. A story that continues even now. And tonight, you have been quietly traveling along with it. Rest well, and let sleepy discovery carry you gently towards sleep. Tonight, we have reached the final part of our long, quiet journey through the fascinating world of chocolate. So if you are already lying comfortably, perhaps with the lights low and the room quiet, there is nothing left to accomplish. You can simply listen. Let the words move slowly. Let the details come and go. And if sleep arrives before the story ends, that is perfectly fine. Tonight's journey began with a tree. A small tropical tree growing in warm, humid environments. From that tree came delicate flowers. From those flowers came colorful cacao pods. Inside those pods were seeds surrounded by sweet pulp. Those seeds were fermented, dried, roasted, cracked, ground, refined, mixed, tempered, shaped, packaged, transported, and eventually transformed into the chocolate that people around the world recognize. It is an enormous journey for something that can disappear from your hand in a few seconds. And tonight, we are going to slow down and appreciate some of the many details that make that journey so extraordinary. Chocolate has become so familiar that it can be easy to forget how unusual it really is. We see it in grocery stores. We see it in restaurants. We see it in bakeries. We see it in vending machines. We see it in gift boxes. We see it in refrigerators. We see it in children's lunch boxes. We see it during holidays. Because it is everywhere, chocolate can feel ordinary. But nothing about its origin is ordinary. The cacao tree belongs to tropical ecosystems. Its flowers are tiny. Its fruits are large compared with those flowers. Its seeds are bitter before processing. Its flavor develops through fermentation and roasting. Its fat has unusual melting characteristics. Its final texture depends on microscopic crystal structures. and its global supply chain stretches across continents. A simple chocolate bar is therefore a meeting point between biology, chemistry, agriculture, technology, history, economics, and human culture. Perhaps that is why chocolate has remained so fascinating for so long. There are very few foods with such a long transformation between plant and finished product. Consider the journey of an apple. An apple grows on a tree. You pick it, you wash it, you eat it. The connection between tree and food remains obvious. Chocolate is different. You can hold a chocolate bar without seeing anything that resembles a cacao tree. The original fruit has disappeared. The seeds have been transformed so completely that most people would never recognize them. The finished product is almost a new material, yet the connection remains. Inside that chocolate is the history of the cacao tree, the history of the farm, the history of fermentation, the history of roasting, and the history of human experimentation. Chocolate is therefore a kind of edible history. Every bite contains traces of decisions made long before the chocolate reached you. The cacao variety mattered. The weather mattered. The farmer's timing mattered. The fermentation mattered. The drying mattered. The roasting mattered. The grinding mattered. The recipe mattered. The tempering mattered. Even the way you store the chocolate matters. And finally, your own senses complete the experience. That is a remarkable chain of events. One of the most beautiful things about cacao is the variety that exists within it. Chocolate does not come from one perfectly identical type of cacao. There are many genetic populations and varieties. Some are associated with particular regions. Some have been selected for productivity, some for disease resistance, some for flavor, some for adaptation to local environments. The world of cacao genetics is much more complicated than the simple categories people sometimes hear about. Modern research has revealed enormous genetic diversity within cacao. This diversity matters because the future of chocolate depends on healthy and adaptable cacao populations. A crop with greater genetic diversity may have more possibilities for responding to future challenges. Diseases change, climate changes, farming conditions change, consumer preferences change. The cacao tree of the future may need to be different from the cacao tree of the past. Plant scientists therefore study cacao genetics carefully. They search for traits that could help farmers produce cacao more reliably. Some traits may help trees resist diseases. Others may influence yield. Others may influence flavor. And some may help cacao tolerate changing environmental conditions. The future of chocolate may therefore depend partly on laboratories studying tiny pieces of plant DNA. It is a strange thought. A chocolate bar in the future could depend on discoveries made under a microscope today. The connection between science and chocolate is much deeper than most people realize. And the future of cacao may also depend on forests. Wild cacao relatives can contain genetic characteristics that cultivated varieties may not have. Protecting wild cacao populations can therefore be a form of agricultural insurance. The forest becomes a living library. Each plant carries information. Some information may already be useful. Some may become useful decades from now, and some may never be used at all. But once genetic diversity disappears, it can be difficult or impossible to recover. This is one reason biodiversity conservation matters, even to people who have never visited a tropical forest. The forests are connected to the foods we eat. Chocolate is one example. Coffee is another. Many fruits, spices, medicines, and agricultural crops have wild relatives living in natural ecosystems. Human civilization depends heavily on plant diversity, and cacao is one small part of that enormous story. There is also a quiet relationship between cacao and shade. The cacao tree naturally occurs in forest environments where larger trees can provide protection from intense sunlight. Farmers can sometimes recreate aspects of this environment through agroforestry. Shade trees can moderate conditions around cacao. They may reduce heat. They can contribute organic material to the soil. They can provide habitat, and they can diversify the farm. A cacao farm with several kinds of trees can look much more like a living ecosystem than a field containing a single crop. This does not mean every shade-grown system is automatically perfect. Agricultural sustainability is complicated. Different systems have different strengths and weaknesses. But the idea of combining agriculture with trees is increasingly important in discussions about climate resilience and biodiversity. Cacao is especially suited to this conversation because of its forest origins. A chocolate future that protects farmers and ecosystems requires more than simply producing more beans. It requires understanding the land. Healthy soil matters. Water matters. Shade matters. Pollinators matter. Disease management matters. Farmer knowledge matters. And long-term economic stability matters. A farmer cannot protect an ecosystem indefinitely if growing cacao does not provide a viable livelihood. Sustainability has to include people. This brings us to one of the most important hidden parts of chocolate: the people who produce it. Chocolate advertising often shows finished products. Glossy chocolate, beautiful desserts, perfectly arranged pieces. But the beginning of the story is usually much less glamorous. It is agricultural work, walking among trees, managing weeds, checking pods, watching for disease, harvesting fruit, opening pods, fermenting beans, drying them, sorting them, moving them. The cacao farmer is the first human link in the chocolate chain. Without that work, the factory has nothing to process. And yet, farmers are often separated from consumers by enormous distances. A person buying a chocolate bar in North America or Europe may be thousands of kilometers from the farm where its cacao originated. That distance can make the agricultural side invisible. The chocolate simply appears on the shelf. But every bar has a beginning. Every bar has a farm. Every bar has a harvest. Every bar has a chain of people behind it. This is why traceability has become increasingly important in the chocolate industry. Traceability means understanding where ingredients came from and how they move through the supply chain. Better traceability can help companies understand farming conditions and identify risks. It can also help consumers make more informed choices. But tracing cacao is not always easy. Supply chains can involve many intermediaries. Beans from different farms may be mixed. Transportation can involve multiple stages. Different countries have different systems. And smallholder farms can be difficult to track individually. Technology may help. Digital records, geographic information, improved supply chain systems, farm mapping, data collection, all can contribute to greater transparency. Again, chocolate connects to modern technology. A cacao tree may look ancient, but the industry surrounding it is increasingly digital. There is also a cultural side to chocolate that has expanded dramatically. Different countries have developed their own chocolate traditions. Some cultures emphasize bars. Others emphasize drinking chocolate. Some have strong traditions of chocolate pastries. Others use cacao in sauces. Some celebrate chocolate through festivals. Others associate it strongly with holidays. The basic ingredient remains cacao, but the cultural expression changes. This is true of almost every food. Rice becomes sushi in one culture, biryani in another, and rice pudding somewhere else. Wheat becomes bread, pasta, noodles, pastries, and countless other foods. Cacao has followed a similar path. It has become a global ingredient with local personalities. One of the most famous combinations is chocolate and mint. The cool sensation of mint contrasts with the richness of chocolate. Chocolate and orange work through a different kind of contrast. The citrus acidity can brighten the deeper roasted notes of cacao. Chocolate and coffee share roasted characteristics. Chocolate and nuts combine creamy richness with crunch. Chocolate and berries create a contrast between sweetness and acidity. Chocolate and chili create warmth against richness. Chocolate and salt can make sweetness feel more pronounced. These combinations work because the human palate responds strongly to contrast. A food does not have to match every flavor. Sometimes the most interesting pairings are opposites. Chocolate is particularly versatile because its flavor contains both sweet and bitter possibilities. Dark chocolate can support strong savory or spicy flavors. Milk chocolate can complement delicate sweet ingredients. White chocolate can act almost like a creamy canvas. This versatility explains why chefs continue to experiment with chocolate. Even after centuries of chocolate making, there are still new combinations to discover. Another fascinating area is chocolate and texture. Chocolate can be used to create shells. A thin layer can harden around a soft filling. When bitten, the shell cracks. Inside, the filling may be creamy. The contrast can be dramatic. Chocolate can also form curls, shavings, ribbons, sheets, spheres, and delicate decorations. Its ability to solidify into a stable form and then melt when warmed makes it useful for pastry work. Professional chocolatiers use this behavior constantly. They heat chocolate, cool it, temper it, spread it, mold it, cut it, decorate it, and allow it to set. A finished chocolate sculpture can look almost impossible, but it is built from the same basic material found in an ordinary bar. The difference is technique. Chocolate is also capable of trapping air. Whipped chocolate preparations can become lighter. Aerated chocolate can have a very different texture from dense chocolate. Tiny air bubbles change the way chocolate breaks and melts. The same ingredients can therefore create completely different experiences depending on structure. This reminds us again that food is not just about ingredients. Structure matters. A chocolate mousse, a chocolate bar, a chocolate truffle, a chocolate cookie, a cup of cocoa. They can all contain cacao, yet they feel completely different. This is partly because of water content, fat content, particle size, air, temperature, and physical structure. Chocolate is therefore a material that can be engineered into many forms. The kitchen becomes a laboratory, and the chef becomes an experimental scientist. There is another fascinating aspect of chocolate: sound. A properly tempered chocolate bar can make a crisp snap when broken. That sound is so recognizable that people sometimes use it as a sign of quality. The snap occurs because the solid chocolate structure fractures suddenly. The crystal network and the surrounding matrix determine how that fracture happens. A soft or poorly tempered chocolate may bend rather than snap. The sound is therefore a tiny sensory signal about microscopic structure. Your ears can tell you something about the cocoa butter. That is an unusual relationship between chemistry and sound. And chocolate has another sensory feature that is easy to overlook: its color. Dark chocolate can range from deep brown to nearly black. Milk chocolate is generally lighter. White chocolate is pale because it contains cocoa butter without the dark cocoa solids. But even within these categories, color can vary. Roasting influences color. Cacao variety influences color. Formulation influences color. Processing influences color. and our expectations are influenced by color. A darker chocolate may be expected to taste more intense. A pale chocolate may be expected to taste sweeter. A brightly colored chocolate product may suggest fruit or another flavor. The eyes therefore influence the way the brain interprets taste. This is true for many foods. But chocolate makes the relationship particularly obvious. A chocolate bar that looks glossy and rich can create expectations before the first bite. The brain begins predicting what will happen. Then the actual sensory experience is compared with that prediction. This is why packaging matters so much in the chocolate industry. The wrapper is not merely protecting the product. It is communicating a promise. Elegant packaging may suggest luxury. Bright packaging may suggest fun. Minimal packaging may suggest craftsmanship. Holiday packaging creates seasonal expectations. The same chocolate could be presented in completely different ways and create completely different emotional impressions. Chocolate therefore exists in both physical and symbolic worlds. The physical chocolate has molecules. The symbolic chocolate has meaning. One is chemistry, the other is culture, and humans experience both simultaneously. Think about a heart-shaped box of chocolates. The chocolate itself contains cacao, sugar, fat, and other ingredients. But the box may also represent affection. The ingredients are physical. The meaning is psychological. And the two become connected. This is one reason chocolate appears so often in romantic traditions. Its richness, sweetness, and luxury associations make it an easy symbol of indulgence. But chocolate also represents comfort. A person may reach for chocolate during a difficult day. The food itself cannot solve the problem, but the familiar flavor can provide a moment of pleasure. Food rituals can become emotionally meaningful. Perhaps someone grew up eating chocolate cake on birthdays. Perhaps hot cocoa was served during winter. Perhaps chocolate was associated with family gatherings. Over time, the food becomes linked with memories. The chocolate does not contain the memory. The brain does. But the flavor can act as a trigger. A smell can bring back an old moment almost instantly. This is one of the reasons food memories can feel so powerful. And chocolate has an enormous collection of them. There are childhood memories of Halloween candy, birthday cakes, holiday desserts, chocolate milk, cookies, brownies, ice cream, gift boxes, Easter treats. A chocolate flavor can transport someone backward in time. Perhaps that is part of the reason chocolate feels comforting. It can connect the present with the past. There is also a connection between chocolate and creativity. Chocolate is used by pastry chefs, confectioners, artists, and sculptors. Large chocolate sculptures can be built for competitions. Some can resemble buildings, flowers, animals, people, abstract designs, entire landscapes. The material is temporary. Heat can destroy it. Humidity can affect it. But while it exists, chocolate can become a form of art. This is another reminder that cacao has traveled remarkably far from its agricultural origin. A cacao seed begins as part of a tree's reproductive system. Humans eventually transform it into a sculpture. That is an extraordinary cultural journey. Chocolate has also been used to create elaborate desserts for royal celebrations, weddings, festivals, and special events. Its association with luxury makes it particularly suitable for ceremonies. Even simple chocolate can feel special when presented beautifully. A single truffle placed on a small plate can seem more luxurious than a larger quantity eaten casually. Presentation changes perception. Again, the brain is involved. Food is never experienced through taste alone. We see it, smell it, touch it, hear it, remember it, and imagine it. All of those signals influence the final experience. Chocolate happens to engage many of these systems extremely well. It is visually distinctive. It smells strongly. It has a characteristic texture. It makes a sound when broken. It changes dramatically with temperature. And it has powerful cultural associations. It is almost designed for sensory attention. But perhaps the strangest part of chocolate is its relationship with animals. For humans, chocolate is a common food. For dogs and some other animals, it can be dangerous because of compounds such as theobromine and caffeine. Animals differ in how they process these compounds. This is a reminder that the same molecule can behave differently in different species. Human biology has adapted to many foods, but not every food that is safe for humans is safe for pets. Chocolate should therefore be kept away from dogs and other susceptible animals. The story of cacao in nature is also different from the human chocolate story. Wild animals interact with cacao fruit and forest ecosystems for reasons unrelated to chocolate. They do not see a cacao pod and imagine a candy bar. They are simply participating in ecological relationships. Humans are the ones who created the idea of chocolate. The tree did not evolve to make chocolate. Chocolate is our transformation of the plant. That distinction is surprisingly profound. Cacao exists independently of chocolate. The cacao tree does not need humans to invent a chocolate bar. It needs to reproduce. It produces flowers. It develops fruit. It creates seeds. Humans entered the story and discovered that those seeds could be transformed into something remarkable. Over thousands of years, we kept experimenting. We learned fermentation. We learned roasting. We learned grinding. We learned mixing. We learned tempering. We developed machines. And eventually, we built an enormous global industry. The chocolate bar is therefore a product of human creativity layered on top of natural biology. The natural world provides the raw material. Human culture provides the transformation. This pattern appears everywhere in food. But chocolate makes it especially visible. There is another fascinating transformation in the history of chocolate, the move from beverage to solid food. For much of cacao's early history, drinking preparations were especially important. Modern consumers often imagine chocolate primarily as something solid, but chocolate beverages remain popular. Hot cocoa, drinking chocolate, mocha, chocolate milk, frozen chocolate drinks. Different cultures have developed different versions. The liquid form of chocolate also highlights its relationship with texture. A beverage can be smooth and creamy. A thick drinking chocolate can almost resemble a dessert. A lighter cocoa drink can feel more like a warm beverage. The same cacao can therefore become a completely different experience depending on how it is prepared. There is something comforting about warm chocolate. Perhaps it is the temperature. Perhaps it is the aroma. Perhaps it is the association with childhood. Perhaps it is the combination of sweetness and warmth. Or perhaps it is simply familiar. Humans are strongly influenced by familiar sensory patterns. Warm foods can be associated with safety and comfort. Sweet foods can be associated with energy and reward. Chocolate combines both. This does not mean chocolate automatically makes people happy. Human emotions are much more complicated, but it helps explain why chocolate has such a strong cultural reputation as a comfort food. The scientific study of chocolate also continues. Researchers examine cacao genetics, plant diseases, climate resilience, fermentation, flavor chemistry, human nutrition, sensory perception, manufacturing technology, sustainability, supply chains, and consumer behavior. Chocolate is therefore not a finished scientific subject. There are still unanswered questions. There are still better methods to develop. There are still new cacao varieties to study. There are still new flavor combinations to discover. There are still challenges facing farmers. And there are still questions about how climate change will affect the crop. The chocolate industry of the future may look very different. It may rely on more resilient cacao varieties. Farming systems may become more diversified. Traceability may become more sophisticated. Processing technology may become more precise. Consumers may demand greater transparency. New chocolate formulations may reduce sugar. Some products may emphasize specific cacao compounds. Others may use alternative ingredients. But one thing will probably remain: the cacao tree. Even if the chocolate industry changes dramatically, the origin story remains connected to a plant. And perhaps the future of chocolate will depend on learning to respect that origin more carefully. If cacao farmers are supported, trees can be maintained. If ecosystems are protected, genetic diversity can survive. If sustainable farming practices succeed, cacao can remain productive. If climate resilience improves, future generations may continue enjoying chocolate. The future is not guaranteed, but it is possible. And that possibility begins in the same place where our story began: a tree. There is something deeply calming about that thought. The modern world moves quickly. Factories operate around the clock. Markets change constantly. Technology develops rapidly. But a cacao tree still grows at the pace of nature. A seed becomes a seedling. A seedling becomes a tree. A tree produces flowers. Flowers become pods. Pods mature. The process cannot be rushed indefinitely. Nature has its own rhythm. Perhaps that is why cacao is a fitting subject for a sleep documentary. Chocolate may be fast to eat, but it is slow to create. A single bite represents months of biological growth and careful agricultural work. The finished chocolate may vanish in seconds. The tree took much longer. And this is true of many things we consume. We often see the final product, but not the time required to create it. A loaf of bread hides the time spent growing wheat. A cup of coffee hides the time spent growing and processing coffee cherries. A chocolate bar hides the life of a cacao tree. Food reminds us that time is built into everything. Now imagine a cacao pod again. Perhaps it is deep red, or yellow, or orange. It hangs from the trunk. Inside, dozens of seeds rest together. Each seed contains the possibility of another cacao tree. But humans have found another use for those seeds. We ferment them. We dry them. We roast them. We grind them. We transform them into chocolate. The seed therefore sits between two possibilities. It can become a new tree, or it can become food. That is one of the quiet biological tensions within cacao. The plant creates seeds for reproduction. Humans harvest many of those seeds for consumption. And yet cacao continues to survive because enough trees continue to reproduce, and because humans cultivate the crop. Agriculture changes natural systems. The cacao farm is neither completely wild nor completely artificial. It is a human-managed ecosystem. This is true of many crops. But cacao's forest origins make the relationship particularly interesting. A cacao farm can sometimes resemble a forest. Trees, shade, leaves, flowers, pods, insects, birds, soil organisms, people, all interacting. The best agricultural systems often recognize these relationships rather than trying to eliminate them. The goal is not always to control every part of nature. Sometimes it is to work with nature. This philosophy may become increasingly important as the climate changes. Farmers around the world are already adapting to changing conditions. Cacao farmers may need to adapt too. The future could involve improved shade systems, more resilient planting material, better disease monitoring, improved soil management, water conservation, diversified crops, and stronger farmer support. Technology may assist. Satellites can monitor land. Sensors can measure environmental conditions. Genetic tools can identify useful traits. Data systems can improve traceability. But technology cannot replace the basic relationship between farmer and tree. Someone still needs to walk through the farm. Someone still needs to observe the plants. Someone still needs to harvest the pods. Someone still needs to care. Chocolate remains a human story. The machine can process the bean, but the story began with people learning how to use the plant. That learning happened over generations. Knowledge was passed from one person to another. Communities developed traditions. Techniques evolved. Recipes changed. And eventually, cacao became global. This is why the history of chocolate cannot be separated from the history of the people who cultivated and prepared cacao. The ingredient has traveled across cultures, but its origins remain rooted in indigenous American knowledge and traditions. Recognizing that history gives chocolate greater depth. The modern chocolate industry is only the latest stage of a much older story. Before European factories, there were cacao-growing communities. Before candy bars, there were cacao beverages. Before cocoa powder, there were traditional grinding methods. Before modern chocolate machines, there were human hands. The technology changed. The cacao remained. And the story continued. There is also an interesting linguistic journey. Words for cacao and chocolate traveled between languages as cacao entered new cultures. The exact history of these words is complicated. Languages borrow from one another. Sounds change. Meanings shift. But the modern word chocolate carries traces of this long cultural journey. A word that now appears on menus, wrappers, advertisements, and grocery lists has a history stretching back centuries. Language itself has eaten chocolate, and chocolate has changed language. There are phrases built around it. Chocolate lover, chocolate cake, chocolate bar, hot chocolate, dark chocolate, milk chocolate, white chocolate, chocolate chip, chocolate covered, chocolate flavored. A single ingredient has become a linguistic category. This is a sign of cultural importance. When something becomes deeply integrated into everyday life, language grows around it. And perhaps one of the most familiar examples is the chocolate chip. Small pieces of chocolate became an essential ingredient in cookies and other baked goods. The combination of a soft or crisp baked dough with melting chocolate created a completely new sensory experience. The chocolate chip cookie became one of the most recognizable chocolate foods in modern culture. The principle is simple. Chocolate is added to another food. Heat changes it. The chocolate softens. Some parts melt. The cookie remains structured. When it cools, the chocolate changes again. The result is a mixture of textures. Warm cookie, soft chocolate, crisp edges, sweet aroma. It is another example of chocolate acting as a material rather than merely a flavor. Chocolate can be part of a structure. It can be the structure. It can be a coating. It can be a filling. It can be a decoration. It can be the main ingredient. Its flexibility is one of its greatest strengths. And there are countless chocolate desserts around the world. Cakes, tarts, mousses, brownies, puddings, truffles, pralines, bonbons, cookies, pastries, ice creams, sauces, candies. Each one uses chocolate differently. Some emphasize bitterness, some sweetness, some creaminess, some texture, some aroma, some visual presentation. Chocolate is almost endlessly adaptable. This adaptability may explain why chocolate has remained relevant across changing culinary fashions. Food trends come and go. Chocolate remains. People create new desserts around it. Then new generations create more. The ingredient keeps changing shape, but the underlying cacao remains recognizable. There is also something fascinating about the word cacao versus cocoa. The terms are often used differently depending on context, region, and product. Cacao is commonly used when discussing the tree, beans, and agricultural side. Cocoa often appears in discussions of processed products such as cocoa powder and cocoa butter, but usage is not perfectly consistent. The words can overlap. This is another reminder that food language is messy. Scientific terminology and everyday language do not always match perfectly. The same thing happens with bean. A cacao bean is called a bean, but it is botanically a seed. Food language is full of these convenient names. What matters is that everyone understands what is being discussed. Chocolate is full of such little linguistic quirks. Chocolate liquor contains no alcohol. Cocoa beans are seeds. White chocolate contains cocoa butter, but generally no cocoa solids. The world of chocolate is filled with tiny surprises. And there is one more important surprise. Chocolate does not have one universal flavor. Even the idea of chocolate flavor is broad. A cacao from one place can taste dramatically different from another. Fermentation can alter the flavor. Roasting can alter it. Conching can alter it. Recipe formulation can alter it. Storage can alter it. And the person tasting it can alter the perception. This means that chocolate is partly objective and partly subjective. The chemical composition can be measured, but the experience is personal. One person may love bitterness. Another may prefer sweetness. One person may notice fruit. Another may notice nuts. One may love dark chocolate. Another may prefer milk chocolate. There is no single correct chocolate. There are simply different sensory experiences. This diversity is part of the fun. Chocolate allows people to explore preferences. Perhaps someone begins with sweet milk chocolate. Later, they discover dark chocolate. Then they discover single origin chocolate. Then cacao nibs. Then hot drinking chocolate. Then chocolate paired with coffee. Then chocolate with sea salt. The journey can continue indefinitely. There is always another version, another origin, another recipe, another texture, another percentage, another combination. Chocolate is a world rather than a single food. And tonight, we have only touched some of that world. We have not tasted every cacao. We have not visited every farm. We have not explored every chocolate tradition. We have not experienced every manufacturing method. There will always be more to discover. Perhaps that is fitting. A story about chocolate should never really feel finished, because chocolate itself is always changing. New products appear. New research is published. New farming methods develop. New flavors become popular. New generations create their own traditions. The story continues. But for tonight, our journey is coming to a gentle close. So let's return to the beginning. Imagine a tropical forest. It is quiet. The air is warm. The canopy above filters the sunlight. Leaves move gently. The soil is alive beneath your feet. And among the trees stands a cacao tree. It is not enormous. It does not look particularly dramatic, but it carries the beginning of everything we have explored. Small flowers grow from its trunk. Tiny insects move among them. Some flowers become fruit. A cacao pod develops slowly. Its skin changes color. Inside, seeds mature. Eventually, someone harvests the pod. The pod is opened. The seeds are removed. They are placed together with their sweet pulp. Fermentation begins. The temperature rises. Microorganisms become active. The beans change. Then the beans are dried beneath the tropical sun. They are sorted, stored, transported. Perhaps they cross an ocean. Perhaps they travel by road. Eventually, they arrive at a chocolate factory. There, the journey becomes mechanical. The beans are cleaned, roasted, cracked, winnowed, ground, refined, mixed, conched, tempered, molded, cooled, wrapped, packed, shipped, displayed, purchased, opened, and finally, eaten. The entire journey ends with a small sound. Snap! A piece breaks away. Then the chocolate begins to melt. The cocoa butter warms. The aromas rise. The sweetness appears. The bitterness follows. The texture becomes smoother. And gradually, the piece disappears. A journey that began months or years earlier is completed in seconds. But perhaps the journey does not truly end, because the experience becomes a memory. Maybe you remember the flavor. Maybe you remember the moment. Maybe you remember the person who gave you the chocolate. Maybe you remember a birthday, a holiday, a rainy afternoon, a childhood kitchen, a quiet evening. Chocolate becomes part of your personal history. The cacao tree becomes part of your memory without you ever having seen it. That is one of the remarkable powers of food. It can connect distant places and times. A tropical tree can become a memory in a person's home thousands of kilometers away. A farmer's harvest can become part of someone's celebration. A centuries-old crop can become part of a modern evening routine. Food connects us, and chocolate is one of the clearest examples. There is something comforting about knowing that beneath all the complicated science and global trade, the beginning is simple. A tree, a flower, a fruit, a seed. Nature does not need a factory to begin the story. The factory only continues it. And perhaps that is the quiet lesson hidden inside chocolate. Good things often take time. The cacao tree takes time. The fruit takes time. Fermentation takes time. Drying takes time. Roasting takes time. Refining takes time. Tempering takes time. And even flavor itself takes time to develop. Modern life often encourages speed, but chocolate reminds us that some transformations cannot be rushed. There is a rhythm to nature, a rhythm to agriculture, a rhythm to fermentation, a rhythm to cooking, and perhaps there can also be a rhythm to rest. Slow, gentle, unhurried. Tonight, you do not need to remember the chemistry. You do not need to remember the history. You do not need to remember the names of cacao varieties. You do not need to remember the details of fermentation. You can simply let the ideas drift away, like leaves moving in a tropical breeze. The cacao forest is becoming quiet. The sky above it is dark. The stars are appearing. The trees are silhouettes. The pods hang quietly. The insects are still moving among the flowers. The forest continues its work. No hurry, no pressure, just growth. And somewhere far away, perhaps a chocolate factory has finished for the night. The machines have slowed. The lights have dimmed. A batch of chocolate rests quietly after being tempered. It has cooled into its final shape. Tomorrow, someone will package it. Someone will transport it. Someone will place it on a shelf. Someone will buy it. But tonight, it simply rests. And perhaps you can do the same. You have followed the story of chocolate through forests and farms, through ancient cultures and modern factories, through biology and chemistry, through history and human memory. You have seen how a small seed can become one of the world's most recognizable foods. You have seen how tiny insects can contribute to the life of a cacao tree. You have seen how microorganisms can transform raw cacao. You have seen how heat creates aroma, how cocoa butter creates melting, how crystals create snap, how tiny particles create smoothness, how packaging protects flavor, how culture creates meaning, and how memory turns food into something personal. All of these things exist inside the word chocolate, a simple word, a complicated world. And perhaps the next time you see a chocolate bar, you will see it a little differently. You may see the forest behind it, the farmer, the cacao pod, the seeds, the fermentation, the sunlight, the roasting, the grinding, the patient work, the long journey. And then, perhaps, you will simply enjoy the chocolate. Because after all the science, history, and complexity, chocolate is still meant to be experienced. A small piece, a quiet moment, a familiar aroma, a little sweetness, a little bitterness, a soft melting texture, and then it is gone, just like a thought, just like a dream, just like the sound of rain fading into the distance. So now, as our final chapter comes to an end, allow yourself to become completely comfortable. Let your breathing slow. There is nowhere you need to go, nothing you need to solve, nothing you need to accomplish. The day is finished, the story is finished, and the cacao forest is waiting quietly in the distance. Imagine the leaves moving gently. Imagine the warm night air. Imagine the trees standing beneath the stars. Imagine one cacao pod hanging peacefully from the trunk. Inside it are seeds, and inside those seeds is the beginning of another journey. Perhaps tomorrow, somewhere in the world, another cacao pod will be harvested. Another batch will ferment. Another farm will dry its beans. Another factory will roast cacao. Another chocolatier will temper chocolate. Another person will open a wrapper. Another chocolate bar will make that familiar little sound. Snap. And another tiny piece will begin to melt. The story will continue. Because chocolate is not really a story with an ending. It is a cycle. Trees grow. Flowers bloom. Pods develop. Seeds form. Farmers harvest. Cacao is processed. Chocolate is created. People enjoy it. And cacao trees are planted again. The cycle continues through generations. And perhaps that is the most peaceful thought with which to end. The world keeps moving. Nature keeps growing. Trees keep breathing. Seeds keep developing. And there will always be another morning. Another harvest. Another season. Another story. For now, though, you can rest. Let your mind become quiet. Let the details dissolve. The cacao tree can remain in your imagination, standing peacefully beneath the tropical canopy, the leaves moving slowly, the night air passing through the branches, the stars above, no machines, no traffic, no notifications, no deadlines, only the forest, only the tree, only the gentle rhythm of nature. And perhaps, somewhere in that peaceful scene, you can imagine the faintest aroma of roasted cacao drifting through the night air. Warm, deep, comforting, familiar, and slowly the aroma fades. The forest becomes quieter. The leaves become softer. The stars seem farther away. Your thoughts become slower. Your breathing becomes deeper. Your body becomes heavier against the bed. There is nothing left to learn tonight. You have already traveled far. From a tiny flower to a cacao pod. From a seed to a fermented bean. From a roasted cacao bean to smooth chocolate. And from chocolate to a story. Now the story can rest. So close your eyes if they are still open. Take one slow breath and let it go. Another slow breath and let your shoulders relax. One more gentle breath and allow the day to disappear. The cacao forest is quiet. The chocolate is still. The night is peaceful. And sleepy discovery is slowly fading into the background. Perhaps tomorrow you will remember a detail. Perhaps you will remember nothing. Either is perfectly fine. Sleep does not require memory. You do not have to hold on to the story. You can simply let it pass, like a cloud, like a breeze, like a distant sound. And as you drift towards sleep, remember only this simple image. A cacao tree beneath a quiet tropical sky, its leaves moving gently, its flowers resting against the trunk, its pods hanging peacefully, growing slowly, patiently, naturally, the beginning of chocolate, the beginning of a journey, and perhaps, in the quietest way, the beginning of a dream. Good night. Sleep deeply, sleep peacefully, and thank you for spending this quiet journey with Sleepy Discovery. Until the next story, let your mind rest, let your body relax, and let the night carry you gently into sleep.